Hello and welcome. I'm very excited that you are joining me in this online course in which I will teach you everything that you need to know about building strength and power. If you ever have any questions or comments along the way, along this journey in this online course, please feel free to let me know by reviewing this online course and leaving a comment or by sending me a personal message on Udemy. Anyways, let's get started with the first section. In this first section, I would like to give you a quick introduction about this course, about all the topics that we're going to cover, and give you some other knowledge that is worth knowing before we officially start it with the first main topic in section 2. So in this first chapter, I will show you the course structure and I'll give you an overview about all the different topics that we're going to cover. So what can you expect to learn in this online course? You're basically going to gain a general understanding of how our muscles are functioning, how we produce movement. You will learn about all the strength qualities and their importance to training, and also how to implement all of these concepts into your training. And lastly, you'll learn how to optimize training adaptations and recovery to make training as efficient as possible. Who is this course especially designed for? If you are an athlete that wants to build strength and power for especially your sport, then this course is great for you, as well as if you're a trainer or a coach that aims to improve your clients' results, or if you're just anybody that's interested in learning about sport-specific training, sport-specific strength and power training. Now, the concepts that I'm teaching you in this course, they are applicable for every single sport. So whether you're an endurance athlete or a strength and power athlete, or you're doing a team sport, whatever you're doing, those principles go well with any sport. Let me give you a quick overview about each single section. So in section 2, we will cover everything about the muscle structure. So that's going to include questions like, how do muscles work? What types of muscles are there? And how exactly do we produce force? How can we utilize our muscles in order to optimize force generation? Section 3 will cover everything about how muscles operate. So which types of muscle contractions are there? How should these contraction forms be trained exactly? And why are they even important for us to train? And also about how muscle operations translate to sport or to our sport in particular. In the next section, section 4, we'll dive into the nervous system and motor control. So we're going to talk about what exactly is the nervous system in general, what are the different components of it, how is the nervous system even related to our muscles and to our performance and to building strength and power, and also the importance of the nervous system for training, for our gains, and also for reducing injuries. After that, in section 5, we'll get to the strength qualities. So we'll talk about which strength qualities are there. You will learn about which strength qualities do we even need for sport or for your sport in particular, and how we train each one of these qualities. In section 6, we will get more detailed into training. We'll talk about different training principles. So here I'll tell you how the concepts that we'll talk about before are going to apply to sport or to your sport. Section 6 will also be about how to plan and how to structure your workout to get the outcome that you want and to train in a way that's fitting to your sport. Then in section 7, we'll talk about the adaptations that we get from training. So how do muscles adapt after an exercise, and also how we can maximize our gains while limiting the recovery time. Basically, section 7 will be about how we can optimize our training outside of our workout itself. So we're also going to cover different recovery methods. Lastly, there'll be a bonus section about creating your own training program. So here I'll introduce you to the concept of progressive overload and how to apply it the right way. We're talking about how to plan your training long term and to create individualized training programs, and also in general all other factors that we have to consider when creating training programs. In addition to this online course, there's some content that you have access to and that should help you in applying all the concepts that you learn here. So we have an exercise library. We have a checklist about the daily habits that you can implement into your lifestyle when you're training for strength and power. There's a document with nutrition and food ideas that can help you to eat fitting to your training. And there's a muscle map that shows you the most important muscles of the human body that you should know. I wanted to include this topic in section 1 as well, about setting training goals. Now, when we are training, we always need to have a goal that we can build our training program and our workouts around. It's important that our training goals are realistic. So can we even theoretically achieve them, and that they're specific? So saying, I want to jump higher is not a very specific training goal. You should rather say, I want to be able to dunk, or I want to be able to touch the rim when you're a basketball player. Therefore, you should plan your training in harmony with your training goals. That means don't just do anything because you think doing something is better than nothing, but I want you to plan your training so that you can reach your training goal. And that's what I would like to help you with in this course. You should also stick with your training and don't just start doing tons of exercises, because more is not always better. Many people that are working out, they think you need to have that no pain, no gain mentality. So you need to give it your all. You need to be gassed after every single workout. And if you don't suffer, you're not getting anywhere. Well, that might be good for some sports, but if we're training for strength and power, if we want to improve our maximal strength, if we want to jump higher, then that mentality is not going to get us anywhere. It's counterproductive, in fact. Basically, we want to limit ourselves to do only the training that's necessary for us to improve at our specific task. And for some things, that might be this no pain, no gain mentality. If you're training your mental state, if you're training for endurance, to push through something, for some things that might be good to have this mentality, but not always. According to that, quality goes over quantity. It's better to do 5 reps as good as you can with the great technique and as explosive as possible than to do 10 reps where on some of those reps the technique is lacking or whatever. So try to do every exercise as good as you can and choose quality over quantity. Another thing that's very important when setting training goals is to be consistent. Of course, everybody has those days or those phases where they just don't feel like exercising, they're lacking motivation, but you should find a way to at least do a little bit during those times. It's better to work out just a few minutes on multiple days a week than to train for 2 or 3 hours only once a week. If we're trying to do everything at once, our body won't be prepared for it and won't be able to handle those high loads and therefore put us at a high injury risk. Try to force yourself on training days, if you're not motivated at all, to at least do one single exercise. Now, sometimes once you get started, you do one exercise, you're going to do another and a third, and then motivation automatically sets in. Now, if that's not the case, it's fine. You still did your one exercise and you can move on. Lastly, be patient with your training and your training gains and adaptations. We are all different. Some people, they're going to see results much faster. For other people, it's going to take some time. It's very important that you stay patient, that you keep believing in it, and that you stay consistent. And at some point, you will get rewarded. You will see those adaptations. Depending on who we are, what our sport is and what we're training, sometimes it can take weeks until we see something. And in those times, it's just important that we stay with it, because at some point, suddenly, after it was flat, we barely saw any progress, it will go up and we'll see a lot of progress at some point. If you're staying patient and consistent, then I promise you, you will get rewarded. Obviously, your training goals, they depend on the sport that you're doing. So this graphic kind of shows you the strength power to endurance spectrum. Each sport lies somewhere on the spectrum. So on the very left, near maximal strength and power, barely any endurance, we would have a 100-meter sprint, or we would have some heavy weightlifting. On the opposite side, we have endurance. So that includes sports like marathon or triathlon, everything that goes for a longer time and does not require maximal strength or power. Now, other sports like football, tennis, handball, whatever, they are somewhere in the middle of that spectrum. So we obviously need some endurance for the sport, but in some situations we also need strength or power when we have to perform a maximal jump, for example. Depending on where your sport lays on that spectrum, your training goals will differ, obviously. So your training program will be quite different if you're training for strength or power, or if you're training for endurance. The other topic that I wanted to include in section 1 is the mentality that you need for training and for perfect training adaptations. So what's very important to know, our gains, they start with our mentality. So the mentality that we have is mainly going to be responsible for how quickly and how severe our training adaptations will be. You should try to perform every single exercise with a purpose. So don't just perform the exercise in order to perform the exercise. Try to do it as good as you've never done it before. With every single exercise that you're doing, you should have this approach of doing it as well, as explosive as never before. So let's say you're working on your vertical jump, you're jumping up, so you should try to have that mindset of jumping higher as you've ever jumped before in your whole life. That should be your approach to exercise. If you have that mindset, and it takes lots of concentration and mental focus to have that mindset, you will adapt much faster. You will see faster results from your training. In addition to that, you have to believe in your improvement. If you're basically thinking, I'm already at my maximum, like I can't build more muscle, I can't jump higher, I can't sprint faster, then that's going to be the case because you limit yourself with that belief. It all starts with the brain. Now, the brain is a component of the nervous system, and if you convince your brain that you can improve and that you will improve, it's going to help you to activate and recruit more muscle fibers and therefore be more explosive and get better adaptations. Now, visualizations before, during, and after workouts, they can help you to gain that right mentality that you need when working out. So before training, you want to get in that pre-workout zone, how I call it, where you are preparing your mind state for exercise. You are getting in that mindset of, okay, now I'm trying to have the best workout that I've ever had. Now, during training, don't be on your phone. After one set, don't check your phone and reply to a message or something. Try to stay off your phone during the whole workout, and during the resting period between two sets, you should be focusing on the next set and try to do it even better than the previous set. The post-workout zone is in the evening before you go to sleep, for example. You can try to visualize yourself performing really well at the certain task that you want to improve at. So if it's jumping, try to visualize yourself jumping super high, throwing down a crazy dunk, or whatever your goal is. Now, all of those psychological factors are going to help us to improve physically. If you are preparing for competitions or for special workouts, as I've mentioned, you need to get in the right mind state. And those visualizations, preparing your mind for the exercise, they can be very important to prepare for those special moments. Visualizing yourself doing something crazy, doing something special is the first step to actually doing it. Again, if you don't believe you can do it, you're not going to be able to do it. Those visualizations, they can also help you to get into the zone. The zone is this condition in which time and place kind of becomes irrelevant. It's when you're just on fire and everything's going your way and you feel like you have limitless endurance, limitless strength, and nothing can stop you. It's this feeling that you get into when you're competing sometimes. Now, to get into that zone requires an unconscious mind state. That means we cannot consciously think about it. We cannot, when we're sprinting, think about every single step. There's way too many things that need to go perfect at the same time. And that's why we should try to not think at all and just rely on our skills. And that takes lots of confidence, lots of mental focus, and lots of practice. With that being said, we are moving on to section 2 and are going to start with the first main topic of this online course. Welcome to section 2. Let's get officially started with the first topic of this online course, which is going to be the muscle structure. Now, section 2 will cover topics like what kind of muscles are there, how do muscles even work, and just in general, everything that you need to know about muscle when building strength and power. Now, the whole physiology of muscles could be covered in a whole separate online course, which is why I will only give you the most important information that's most relevant for you when building muscle, when building strength and power for your sport. The first chapter of section 2 will be about the different types of muscles that there are. So let's get right into it. As you can see, there are 3 different types of muscles: the smooth muscle, the cardiac muscle, and the skeletal muscle. Now, the skeletal muscle is different from the other 2, and it's the one that we refer to when we talk about building strength and power. Usually when we talk about muscle training, we mean the skeletal muscle, but I will just give you a quick overview over each 3 of these different muscle types. Now, the smooth muscle is involuntarily controlled, which means that we cannot consciously, actively control it. For us, that just means it works by itself. Smooth muscle appears around our organs, so they line the insides of our organs and therefore are responsible for the movement of the gastrointestinal tract, also the expansion of blood vessels, and just to give our inner organs its function and its form and to help them contract. One example for smooth muscle would be the intestines that are working day and night, even while we sleep, digesting the food, and we're not actively controlling it. The second muscle type is the cardiac muscle, also known as myocardium. It's just like the smooth muscle, involuntarily controlled, and as you might have guessed, it's only located at the heart, nowhere else in our body, and it's therefore responsible for the contraction of our heart, so pumping and therefore supplying our whole body with blood, and also transporting and providing our body with oxygen. Though we cannot voluntarily control our cardiac muscle, we can still train it automatically by exercising. So when we exercise, our heart is pumping fast, our heartbeat goes up, and that's how the cardiac muscle gets trained. As I've mentioned before, when we talk about muscle training, strength and power training, we refer to the skeletal muscle, which is why it's the most important for this course for us. And of course, it's voluntarily controlled. We can control our movement consciously. The skeletal muscle is linked with nerves that are connected to the brain and the spinal cord, which we will cover more in depth in section 4. Now, the skeletal muscle is responsible for keeping the body upright and for moving in general, of course. It also supplies our body with energy by maintaining the optimal body temperature, and it is responsible for increasing physical and psychological well-being, which both have an effect on the immune system and the metabolism. To sum it all up, the main tasks of muscles are maintaining the body tension. It acts like a heating system for our bodies. It enables us to move, and it's ensuring our internal body functions. Now that you know what skeletal muscles are, let's look at the structure of skeletal muscle. Muscles attach on two different bones, and the tendon forms the connection between the muscle and the bone. In this example here, as you can see indicated in red on the right side, we have the gastroc muscle, which is one of the calf muscles. While the muscle contracts, one attachment side stabilizes, which is known as the origin, and the other attachment side pulls and is known as the insertion. So with the contraction of a muscle, the sides, they get pulled closer together and the movement gets created, and the joints, they move and they change their angles. We also differentiate between monoarticular muscles and polyarticular muscles. Monoarticular muscles means that the muscle only attaches to a single joint, while in polyarticular muscle attaches to several joints in order to provide stabilization at one joint and to pull at the other. In this example here, we have a polyarticular muscle, as the knee and the ankle are both involved in the movement. While moving, we have two players that are involved, which are known as the agonist and the antagonist. Now, the agonist is the primary muscle involved in a movement, and the antagonist is the primary muscle opposing the movement, which is extremely important for controlling the movement and decreasing the momentum. Now, down here we have an example on the left side. We have a bicep curl, while the biceps is the agonist and the triceps acts as the antagonist. So the triceps is responsible for slowing down and controlling the movement, which is extremely important when contracting muscles, of course, always. So they're both extremely important. We might think the agonist, well, it's the primary mover, but the antagonist, in this case, the triceps, is also very, very important. On the right side here, we can see just the opposite. We have a triceps extension, for instance, where the triceps is the agonist and the biceps, in this case, is the antagonist. Let's look at how exactly a skeletal muscle looks like. This graphic here breaks it down kind of to a hierarchy. We start from the muscle level and go down to the fascicles. Fascicles, they have a diameter of around 1 millimeter, and altogether they form one muscle. From the fascicles, we go down to the muscle fibers or the muscle cells. Now, a lot of muscle cells, they all create a single muscle fascicle. Also, they can be tens of centimeters long while having a diameter of around 50 micrometers. On the next level, we have the myofibrils that altogether make up a single muscle fiber, and they contain more than 50,000 sarcomeres in series. One level down again, we have the thick and thin filaments, or the sarcomeres, which are about 3 micrometers long. So how do we produce force in this hierarchy? Well, each of the thick filaments is called myosin, and they generate a tiny bit of force, only a few piconewtons, but with the sum of all of these filaments together that are arranged in the whole hierarchy, thousands of newtons can be produced. Let's look at how muscles actually contract. There is a leading theory as to how muscles contract, which is known as the sliding filament theory, and it describes the sarcomere that consists of two proteins called actin, or the thin filament, and myosin, which is known as the thick filament. Now, these two proteins, actin and myosin, they line up parallel and are connected with cross bridges. This graphic shows the sliding filament theory and how muscle contraction actually works. On top, we have a myofibril that's divided in different zones. One zone, which is the A band, and contains both the thick and the thin filaments, and at the same time makes up the center of the sarcomere. The I bands are the region that contains only the thin filaments, so only the actin. If we take a look at a single sarcomere, or here at two sarcomeres, we have the Z disc that defines the boundaries of each sarcomere, and the M line, that's kind of the center that marks the center of the sarcomere, going through the middle of all the myosin filaments. Now on this sarcomere level, the thick filament, which is the myosin, and the thin filament, which is the actin, they can kind of start winding and unwinding together like a spiral, which makes both filaments slide past one another. So the muscle doesn't actually get shorter during the contraction. It's just that the actin and the myosin filaments, they start overlapping. There's not actually a change in the length of the filaments or the muscle itself. This whole process of winding and unwinding is known as the cross-bridge cycle, which we can see in the next slide. The cross bridges are what connect the actin and the myosin and allow the sliding of the filaments. The whole cross-bridge cycle is pretty complex, and it goes very much into the biochemical details. The ATP, which is the molecule for energy production that acts like a fuel in this case, binds with the myosin head. Then the myosin head detaches from the actin, rotates forward, and attaches with the next binding site of the actin. The next step is known as the power stroke, where ATP gets released, which generates just a few piconewtons of force that make the filaments slide past one another. This whole process happens very fast, with lots of cross bridges working simultaneously all over the muscle, all over the body during the muscle contraction. Next, let's look at the force-length relationship of the sarcomere. This graph here shows the active force-length curve, and as you can see, the maximal force that gets produced by the sarcomere changes depending on the current muscle length. So when the overlap between the cross bridges, the myosin heads and the actin binding sites, is maximal, that's when maximal force can be produced. Now in this first part of the graph, we're at a decreased muscle length, where the force increases. We have an ascending region. Then we get to a normal, where we hit a plateau. That's where the maximal force production is possible. After that, we have an increased muscle length. The region is descending and the force decreases. When we look at the optimal fiber length, of course, we want to be in this normal area where we hit this plateau, because that's where we can produce maximal force. Now, what's very important to know here is that muscles with longer fibers have broader active force length curves. So the longer the muscle, the broader the active force length curve. So high forces can be generated over a longer muscle span. That means the plateau has an increased length. Also, muscles with longer fibers have a higher maximal shortening velocity. That means those muscles, they can contract faster and thus perform more explosive movements. Now, this is very important to know for training, that muscles that are longer, they have usually higher shortening velocities and are more explosive therefore. Ultimately, we can say that the optimal fiber length of the muscle is where we can develop the highest force while having the highest shortening velocity of the sarcomere. Apart from the active force-length relationship, there's a passive force that we need to consider, and it's made up out of titin on the one end. We talked about titin in the previous chapter. It's a large flexible protein and attached to the Z discs at either end of the sarcomere. Now, the titin increases its stiffness when the length of the sarcomere increases. So you can kind of compare it to a rubber band. When you pull on the rubber band, the stiffness increases with an increased sarcomere length or an increased rubber band length. Now, the connective tissue has similar behavior regarding the force-length relationship, just like the titin. The green graph here shows the passive force that only gets active at an increased sarcomere length. The red graph is the active force length curve that we saw earlier, And now when we add them up, when we combine the red and the green graph, so the active and the passive force, we get a combined active and passive force, which is the total force length curve. Now, the first part of this graph, of the blue graph, looks kind of or just like the red graph, like the active force length curve, but the end is very different. So at the highest possible sarcomere length is where the highest forces are generated. So when the muscle is stretched, the muscles generate forces that are even higher than at their optimal length, even when they're inactive. Next, let's talk about the different types of muscle fibers that there are. Now, we differentiate between slow twitch muscle fibers and fast twitch muscle fibers, but there's actually around roughly 7 to 8 different categories that range from slow twitch to fast twitch. What's also important to know is that different muscles have different quantities of muscle fibers, while some muscles have more fast twitch, others are more slow twitch, so it depends on what muscle we're looking at. First, let's look at the slow twitch muscle fibers. They're known as the type 1 muscle fibers and are activated during slower movements. The slow twitch muscle fibers, they have very high endurance, which means they're more resistant to fatigue. One example here would be a marathon runner or any other sport that goes for a very long time and is kind of not too explosive, not too fast, like more slower movements over a long period of time. On the other hand, we have the fast twitch muscle fibers that are known as the type 2 muscle fibers. They are activated during fast and explosive movements, have a very low endurance. That means they're much less resistant to fatigue. And one example here would be a sprinter or other explosive sports that include high intensity strength and power exercises. Now the fast twitch muscle fibers, they can be categorized again by itself into the type 2A muscle fibers and the type 2X muscle fibers. Now they used to be called type 2B, but nowadays they're actually called type 2X muscle fibers. The type 2A muscle fibers, they're about 5 to 6 times faster than the type 1 fibers. The type 2X fibers, though, they're about 20 times faster than the type 1 and are therefore extremely rare to find in humans. So anybody who has a high amount of fast twitch muscle fibers is capable of producing highly explosive movements, but with a very low endurance. Like we have an increased explosiveness with a reduced endurance. Cheetahs, for instance, are around 95% type 2X. The amount of slow twitch or fast twitch muscle fibers that we have is highly dependent on genetic differences. So everybody has a different potential. Some can develop more fast twitch muscle fibers or slow twitch muscle fibers. Others can develop less fast twitch or slow twitch muscle fibers. Also, the starting position differs. For an average human, it's about 50-50, 50 fast twitch, 50 slow twitch. So they're right in the middle of the spectrum here. But overall, men have up to 10% more fast twitch muscle fibers than women, though there is no difference really in training potential. The spectrum here shows Usain Bolt, who's obviously more on the fast twitch side, and marathon runners that are more on the slow twitch side of the spectrum. Now we will get into a really interesting part, which is shifting muscle fiber types. Can we change or shift our current distribution percentile towards more slow twitch or towards more fast twitch? Shifting our muscle fiber types from fast twitch towards slow twitch is possible, yes, but also switching from slow twitch to fast twitch is also possible. So the common myth out there that we can't shift our muscle fiber types from slow twitch towards more fast twitch is simply wrong. Now, of course, there are genetic differences in our starting position, as mentioned before, but also in our potential of how much percent of especially fast twitch muscle fibers we can gain. Regarding the training of muscle fiber types, now we'll get more detailed into training in a later section, but I just wanted to give you a little overview now to kind of keep it a little bit more practical here. So if we want to shift our muscle fiber types towards more slow twitch, we need to do endurance training. That means low intensity exercises that have a high volume. For example, any endurance training like going for a jog or lifting lighter weights with higher repetitions, basically all slower movements that have a longer time under tension. An indication also for slow twitch fatigue is when we feel our muscles burn after a plank, for instance. Let's say you're doing a normal plank for a few minutes, however long, at some point you will feel a heavy burn in your muscles. That's when those slow twitch muscles are slowly fatiguing. Training towards more fast twitch is more difficult than the other way around. So here we want to aim for a maximal output. So anything that includes maximal speed or maximal force production, like lifting heavy weights or performing maximal effort jumps. It's important that when training fast twitch muscle fibers, that we keep our time under tension, so our volume kind of low, and really go out on every single rep. If our muscles fatigue and we cannot achieve a maximal output, so continuing the exercise despite fatigue would therefore push us more towards that slow twitch side. Training to fatigue and being without energy after the workout is not the goal here. It's an indicator for fast twitch fatigue when we simply cannot perform the exercise at high speed anymore, or we can't lift the weight. So it's more a lack of muscle energy instead of a muscle burn that indicates the fatigue on the fast twitch muscle side. Let's just make something clear here. If you are training for fast twitch muscle fibers, just to let you know, before you avoid any kind of exercise that includes endurance, regular cardio training does not mess up your fast twitch muscle fibers. So, for example, if you go on a daily jog for 20 minutes, that's not going to be enough for you to shift towards that slow twitch side. Only if you expose yourself regularly to that high volume stimulus for, let's say, you're training for a marathon. In fact, we need this aerobic base for our overall health and in order for our muscles to recover easier. So it's actually good to do some regular short cardio training, and it does not mess with your fast twitch muscle fibers. For your sport, you also should maintain at least a little bit of exposure for fast twitch muscle training during the season, because depending on your sport, all of those training and those games, they will shift you more towards that slow twitch side. For example, if you're a basketball player like me, you need to have fast twitch muscle fibers to jump high, to be more explosive. But during the season, you have lots of games and you have lots of training, then you will shift automatically more towards slow twitch. That's why a little bit of exposure to fast twitch muscle exercises is not going to be wrong. It's going to be very good for you, and you should do it, in fact, during the season. Especially during the off season, though, is when you should really go out to train those fast twitch muscle fibers. This is a good time to focus less on endurance and really shift into that fast twitch area. Now, here, of course, the question is, do you need to get more athletic? It's also, of course, depending on your sport. Do you need to be explosive even? If not, then you might want to do less fast twitch muscle fiber training. As you get closer to the start of the season, that's when you shift your focus more on that endurance side. So, of course, you don't want to be out of breath after 5 minutes into a game. So just remember that fast twitch muscle fibers are more fatiguing than slow twitch muscle fibers. The main message that I want to give you in this slide is that we want to build fast twitch muscle fibers in the off season and try to maintain them as much as possible during the season. Of course, again, depending on your sport. Let's look at the different muscle architectures. So there's different types of muscles, different types of ways that muscles are built. We have, for example, unipinnated muscles. That means the muscle only attaches on one side of the tendon. Then we have bipinnated muscles, where the muscle attaches on both sides of the tendon. Then we have multipinnated muscles that have more of a more complex architecture. We also have, for example, parallel muscles. What I really want to get at here is that there are muscles that go in a straight line from tendon to the other tendon, like the parallel muscles, and that there are muscles that are somewhat pinnated and they don't line up straight, So that would be the bipinnated muscles, the unipinnated muscles, or the multipinnated muscles. Check out the muscle map in the additional content section if you want to learn more about the location and the name of the muscles. So why is it important to know about the different muscle architectures that there are? First of all, pinnated means basically feathered, so it's reminiscent of a bird feather. Now, the pinnation angle describes the angle in which the fibers are attached to the tendon. On the picture down here, you can see how it looks like. That's the pinnation angle. So obviously, pinnated muscles have a higher pinnation angle than parallel muscles, for instance. What's also very important to know about is the physiological cross-sectional area, short PCSA, which describes the muscle width, so the amount of parallel muscle fibers. Now, the cross-sectional area is so important because it describes the maximal force that the muscle can produce. The more parallel muscle fibers we have, the more force we can produce. So why is the pinnation angle and the cross-sectional area so important? Well, a low pinnation angle means that we have a smaller cross-sectional area, as we can see in the parallel muscle here, and therefore we have a lower maximal force output, less parallel muscle fibers. And on the other hand, we have a higher shortening velocity because the muscle fibers, they are longer with the lower pinnation angle. Think about the force-length relationship that we talked about. Longer muscle fibers means higher shortening velocities. If we have a high pinnation angle, like on the right side here, that means we have a larger cross-sectional area, so we have a higher maximal force output, but a lower shortening velocity, because as you can see, the muscle fibers are much shorter. Therefore, the force-length relationship tells us shorter muscle fibers, lower shortening velocities. We talked about the contractile components of our body, which is the muscles. Now let's move on to the non-contractile components. The tissue in our bodies that describes non-contractile elements are the tendons and the ligaments. Bones are stiff and don't belong to it anymore. Now, non-contractile opponents are responsible for storing and releasing elastic energy, which is crucial for all kinds of elastic movements like jumps, hops, or sprints. So let's look at each of these three areas individually. The tendons are very strong, flexible, and stiff collagen tissue. You can kind of think of it like a rope. And the longest and largest tendon is the Achilles tendon. Now, they don't only connect muscle and bones, but they also transfer muscle forces to the skeleton. That's why they're so important. Moreover, they are responsible for storing and releasing elastic energy as they stretch and recoil. Another thing that tendons do that's very important for injury prevention is the impact absorption. Let's say we're landing from a jump, our tendons help us to absorb that energy that we get from the landing. Tendons have a tremendous amount of strength. The flexor tendons in the foot, for instance, can handle more than 8 times of the body weight. The two most common tendon injuries are the strain, which is commonly due to hypomobility, which we'll talk about in a later chapter, and the rupture that's usually due to hypermobility. Now to the ligaments. There are more than 900 ligaments in the human body. They are basically connective collagen tissue and are responsible for limiting the degree of freedom for movement. They also connect bones together and keep them in place, keep them together. So they basically stabilize bones, joints, and muscles all together. For example, the knee has 4 ligaments that keep it from moving side to side or backwards. The most known ligaments in the human body are the anterior and the posterior cruciate ligament, short ACL or PCL. Generally, ligaments are also important because they keep our organs in place. Lastly, let's talk about bones. Well, bones, they don't count as non-contractile elements. They consist of hard and strong tissue. They give us structural support and protect the internal organs and nerves. They're also responsible for executing movement. while our muscles produce the movement and the forces get transferred over the tendons to the bones, which ultimately execute the movement. That's why strong bones are required also to absorb the high landing forces, for instance. We have reached the end of section 2. I will see you in section 3. So after section 2 being more biochemical and biological, section 3 will be more practical and more just closer to training. In the first chapter of section 3, we'll talk about the different muscle contraction forms that there are. There are 3 different contraction forms. The first is the isometric contraction, then we have the concentric contraction, and third, the eccentric contraction. So let's look at each of these in particular. An isometric contraction means that there is no change in the muscle length during the contraction. So we contract, we try to hold something, but our muscle length doesn't change, it stays the same. Now, the training advantage for isometric contractions are that the tendon stiffness and the health gets increased. Isometric contractions are also very safe to perform and are the safest of the 3 contraction forms. Since there are no changes in muscle length, the tendon also doesn't get strained and obviously stays at the same length, which improves its capability of translating forces to the bones. Isometric contraction can be divided into yielding isometrics on the one end. Here, the contraction is opposed by a resistant, for example, holding the body in a specific position. The example that's shown here is the plank. So we are holding one position and just trying to hold it as long as possible. The other category of isometric contractions are the overcoming isometrics. Here, the contraction is opposed by a static object. For example, we're pushing against a wall. We're trying to overcome the resistance. We're not just pushing against it. We're trying to push it as hard as possible and try to move the object. Obviously, a wall, we're not able to move it, but we're trying to overcome resistance. During the concentric contraction, the muscles shortens while contracting, and this time actually overcoming a resistance. Concentric contractions are therefore the main driver for all explosive movements. If we're starting from a sprint, if we're jumping up, most of our muscles, they're working concentrically, they're shortening and trying to be explosive. Now, if you think back to the agonist and the antagonist during concentric contractions, our agonist, in this case our biceps, is contracting concentrically, so it's shortening, and the antagonist is lengthening, so it's working eccentrically. During eccentric contractions, the muscle lengthens while contracting, so the resistance is greater than the force that's being generated. Eccentric contractions, they can occur voluntarily or involuntarily. Voluntarily, if let's say, we're walking downhill, we're walking down a mountain, most of our leg muscles, they are lengthening and therefore are voluntarily contracting eccentrically in a controlled fashion. While when our muscles are fatiguing, we're holding a weight and we simply cannot hold it anymore. It's an involuntary eccentric contraction. So we cannot hold the weight and it's lowering because there's just a lack of strength. Through eccentric training, by lengthening our muscles, we can get a plastic change in the sarcomeres. Also, eccentric training induces 90% of muscle soreness. Whenever you feel very sore and worked up after a workout, it's probably due to eccentric training. During most sporting movements, all 3 of the contraction forms appear. So there's not one contraction form that we should always train. It always depends on your sport, obviously, but most sports include all 3 contraction forms. As an example here, I have a counter movement jump. In the first part of the counter movement jump, we're standing still and then dropping down into a squat position. So our muscles are lengthening, which is an eccentric contraction. In that squat position, we need to slow down and stop our eccentric forces and our body weight rapidly. So our muscles are working isometrically in this case. And from that squat position, we explode as fast as possible out to jump as high as we can. So we have a concentric contraction there. Now, during the landing, which we cannot see anymore on this graphic here, we are working again eccentrically as we're landing and we're dropping down into a position again where we need to absorb the forces and our muscle are lengthening and are stopping in an isometric position. So as you can see, counter movement jumps and many other, almost all movements in sport, they are combined contractions. They include all three of the contraction forms and all three of them are very important. In a later chapter, we'll get to when exactly and how should we train isometric, eccentric or concentric contractions. The force is not just dependent on the length of the muscle, but also at the velocity that our muscle is contracting at. So the amount of force that our muscles can generate depends on the rate at how the length of the muscle changes, which is the velocity. Our capacity of actively generating forces decreases at high shortening velocity, so all concentric movements, because the actin and the myosin filaments slide past one another faster than the myosin head can actually detach during the power stroke. At high lengthening velocities, though, our active capacity of generating forces increases. So during all eccentric movements, we have higher force generation capabilities. That is because the myosin gets trained before the myosin head can detach from the actin. So the faster our muscle lengthens, the more the myosin gets trained, which means there's higher forces being generated. Of course, if the lengthening velocity is too high and the myosin gets trained too much, we're at risk for muscle injury, for muscle strains, or even ruptures. This graphic here shows the force velocity curve as we just talked about, and we can see the faster our muscle is contracting concentrically, the less force we can generate. On the other hand, the higher our negative velocity, so our eccentric contraction, the more forces we can generate. Basically, what we can conclude out of this is that there's a higher maximal force output for higher eccentric velocities. This relationship between force and velocity is very important, and I need you to remember it. Later in this course, we'll get back to this curve and see how we can train it, how we can optimize it to get the best force output while still performing the movement or the exercise at a high velocity. What is the stretch shortening cycle? We talked about the counter movement jump before, where we start in a standing position, drop down into a squat position and use that energy, that force, that eccentric force from the drop to explode into a jump. Now, during a squat jump, we do not have this counter movement. We start from a drop position and from there we explode into a jump as high as we can. Usually, most people perform better off of a counter movement jump than off of a squat jump. And there are two reasons for that. Number one, during the counter movement jump, there are higher forces exerted into the ground, which leads to a higher impulse and a higher acceleration for the takeoff. Number two is the stretch shortening cycle. So what is the stretch shortening cycle exactly? The stretch shortening cycle refers to our muscles, which are rapidly stretching and shortening again. During exercises like the counter movement jump, we activate the stretch reflex and the muscle-tendon interaction. As our muscles are stretching, we're storing some energy that we release when we recoil our muscles again. You can kind of compare it to a bouncing rubber ball. When you drop it, it touches the ground, it stores the energy from the fall and releases it by bouncing back up. In order for the stretch shortening cycle to work well, our muscle-tendon interaction is very important. Again, I just want to emphasize the importance of tendons. So think about the tendons while training, because most people are just focused on the muscle. But if our tendons cannot transfer the forces properly to the bones, we're leaking energy. So it doesn't matter how much force our muscles can generate if our tendons can't transfer them properly. One method how we can train the stretch shortening cycle are plyometrics, which we'll talk about in a little bit. To sum this slide up, the keyword here is pre-activation, because pre-activation with the SSC, with the stretch shortening cycle, allows us to perform more explosive movements. So the ability to pre-activate our muscles and tendons before performing the actual movement, that's what makes the stretch shortening cycle so powerful and is the reason why we jump higher off of a counter movement jump than off of a squat jump, where our muscles and tendons start in a relaxed state. The stretch reflex describes the muscle contraction in response to the stretching of a muscle. So it describes the muscle, not the tendon. When we talk about elasticity, the stretch reflex, as well as the properties of the tendon, they define our elasticity. So we usually consciously or unconsciously refer to the stretch reflex. Also, 50% of the stored elastic energy comes from the lower leg, which is why especially those structures in the lower leg around the ankle have to be necessarily trained. So as I've mentioned before, the stretch reflex sets in, for example, when we're landing and jumping right back up, keeping the ground contact time short. But here we differ between the fast stretch reflex, also known as a reactivation. Here we have the shortest possible ground contact time while having a minimal knee bend. We're trying to maintain the muscle at the same length almost, while using the energy from the landing, in which we stay stiff. Otherwise, the energy converts into heat. And in this case, up to 93% of the stored energy can return. The fast stretch reflex occurs, for example, while sprinting or when we're jumping super spontaneously for a rebound, landing and jumping right back up. The slow stretch reflex includes a longer ground contact time and a slightly higher knee bend, but still, overall, we try to keep the ground contact time very short. Here, there's less return of the stored energy and more muscle strength is involved to make up for the energy loss. The slow stretch reflex occurs more during a standing jump or when we're accelerating out of a standing position if we don't have that energy from a prior movement to utilize. Let me just give you a quick overview of what plyometrics exactly are. Plyometrics include all movements that have a high magnitude of stretch loads. So we have a very decreased stretch shortening time where the stretch shortening cycle, for example, gets utilized. We use plyometrics especially when we're training for maximal velocity or maximal power. So we're trying to jump as high as possible, as quick as possible. Some examples for plyometrics would be sprints, multi-directional jumps from left to right, or hops, so all kind of quick, explosive exercises. Now, let's look at the meaning of co-contraction. To understand what co-contraction is, we have to look at the agonist and the antagonist again. Co-contraction is the simultaneous activation of the agonist and the antagonist muscles around one joint. So the goal here is stabilization and control of the respective joint. Now, besides the primary antagonist, there's lots of other small stabilizing muscles around the joint that help the antagonist to slow down and control the movement from the agonist and give more stabilization to the whole joint. Now, there's kind of two sides to the co-contraction. Co-contraction in some situations is absolutely necessary, because if there's a lack of it during the landing, we're at a very increased risk of injury. We need to develop the ability to turn co-contraction on and off rapidly and according to situations, which requires very high motor control from our nervous system. If we would always be co-contracting, we wouldn't be able to produce explosive movements, because you can imagine if the antagonist and the stabilizing muscles are active, they kind of slow down, they pull in the opposite direction as the agonist. Thus, we have a limited contraction velocity, since our muscles are working against each other, and the antagonist and the stabilizers, they're slowing the agonist down. During all explosive movements like jumps or sprints, we have to be able to turn off co-contraction, but then when we land, abruptly turn it on again. Looking at our counter movement jump example again, in this case we're looking at the landing. The co-contraction should set in at least 50 milliseconds before the ground contact. This way we're minimizing the injury risk and are also pre-activating. So if we were to jump up again right after the landing, we would be able to reach the maximal force faster and thus be more explosive because of co-contraction, because our muscles are already pre-activated. Let's talk about muscle hypertrophy. We hear about hypertrophy all the time, but what is it exactly? Muscle hypertrophy basically describes the enlargement of muscle cells due to resistance training, so the size of the skeletal muscle grows. Myofibrillar hypertrophy means here that the muscle strength and its density increases, while sarcoplasmic hypertrophy is an increase in the muscle volume and the energy storage. Because obviously we need muscle for strength and power training, muscle hypertrophy is the foundation for building strength and power. There's a few different factors that indicate if we are building hypertrophy or muscle mass. The first one is metabolic stress through exercise, which basically means, or is also known as the pump that we feel when we're training, when we're working out. Second is mechanical tension, which means we increase the time under tension, so we're performing more reps, performing more exercise. The last one is the muscle damage we feel after exercising, or also known as muscle soreness. When it comes to training hypertrophy, the optimal rep range is about 6 to 15 reps, though the most difficult reps, which are around the last 5 usually, are where we really build hypertrophy. So therefore it could be 5 reps overall, or it could be 20 reps overall, as long as there's 5 difficult reps. To increase our hypertrophy, we don't necessarily have to train until muscle failure. In order to build overall muscle hypertrophy, it's also beneficial to train the muscle over the whole length, over the whole range of motion. Keep in mind that when training hypertrophy, we are increasing our co-contraction. So if you want to be quick and explosive, yes, hypertrophy training can be good, but you also need to do explosive plyometrics, quick movements like jumps or sprints. Hypertrophy training is almost always beneficial, especially if you're new to exercise. The question is, how much hypertrophy do we really need? Because at some point, pushing for even more hypertrophy gains can become counterproductive. First of all, it's not for everybody. And the answer, as so many times, is it depends on your sport, how much hypertrophy you need and how much you should build. Let me shed light on some of the disadvantages that hypertrophy training brings with it. First of all, by increasing your muscle size, you increase your body weight. And as muscles are heavier than fat, you get more strength gains, but you also need more strength in order to perform explosive movement, explosive exercises. So here it's not always worth it because the gains in body weight cancel out the gains in explosiveness that you get. If you're not performing your reps at maximal speed, keep in mind that you're also working on your slow twitch muscle fibers, so you're pushing more into that slow twitch area. As we've talked about before, higher amount of slow twitch muscle fibers make it more difficult to contract quickly. So you're going to have a smaller amount of fast twitch muscle fibers, and therefore your contraction velocity will be decreased. Hypertrophy training also increases our co-contraction, which then again limits our ability to produce high velocity movements. Overall, hypertrophy training can transform strength and power, but mainly during the first years of training. Another disadvantage that hypertrophy could bring with it, if you're pushing for more and more muscle size, is an increased internal moment arm length. On the next slide, we'll look into that into depth. What it basically means is that you need more contraction, a higher contraction for the same changes in the joint angle. Let's say you're performing a squat. On the left side, we have an example with less hypertrophy. On the right side, we have more hypertrophy as the quadriceps is much bigger than on the left side. With less hypertrophy, our resulting force, which is indicated with the green arrow here, goes almost directly through our knee joint. If our quads are huge and have a high amount of hypertrophy though, the resulting force on the right side points further away from the knee joint. The internal moment arm length is the distance between the knee joint and the red dots that are the extension of the resulting force. Because of this increased moment arm length, we need to produce higher forces for the same changes in the joint angle. So if we're going back up, for example. Let me give you an example to make that a little bit more clear. Imagine you're holding a weight in your right arm. So the force goes down through your shoulder joint. Now, if you're lifting your arm up, the weight is in your right hand, so the moment arm length between your shoulder and your hand increases as it will get more difficult to hold the weight in your hand. To wrap up section 3, let's cover muscle soreness and fatigue. There are two different types of muscle soreness. The first is the acute muscle soreness, which usually appears during or right after the exercise. It's also known as this burning pain that we get. Acute muscle soreness usually resolves quickly, and it's due to the metabolites that are building up during high-intensity exercises. The other type of muscle soreness is the delayed onset muscle soreness. This type peaks around 24 to 72 hours after usually intense or more unusual workouts. The delayed onset muscle soreness is due to microscopic tears in the muscle fibers and the surrounding tissue. So we have lots of pain and some stiffness the day after, usually. What can we do in order to reduce soreness? One thing that we can do is to progressively overload, which means we start at a low number of reps, and with each workout, we increase the number of reps a little bit. That way we're trying to avoid muscle soreness, so we feel fresh and ready to go for the next workout. Due to the muscle damage that soreness brings with it, so the microscopic tears in the muscle, it's not the best thing to train while being sore, so we want to avoid that if possible. One thing that could help you with soreness, it's very different, it depends from person to person, is foam rolling or stretching right after the workout or right before the workout. The consumption of protein, especially milk protein supplementation like whey protein, is supposed to help you with muscle soreness as well as omega-3 fat acids, for example, like fish oil. But be careful before supplementing with anything and make sure that it's tested by a third party. The last thing that you could do, and it helps also some people more, others maybe a little bit less, is to repeat the exact same workout the next day with lighter weights and less repetitions. So you want to expose your muscles to the same stimulus under easier circumstances. Now, should you be training to fatigue? Well, that depends on your goal and of course on your sport, as the answer is for almost all of the questions. If you're training hypertrophy, probably yes, you want to train to fatigue or nearly to fatigue. If you're training for speed, for explosiveness, no, definitely not. In this case, you want to choose quality over quantity. You want to perform your reps as well as possible with the maximal speed, and you are not aiming for fatigue. Endurance training is another example when we want to train all the way to fatigue. For example, when we're doing burnout drills. In order to avoid overtraining, it's extremely important that you do not train to fatigue every single day. You might feel like you have the energy to train to fatigue every day, but just don't do it. Alternate between high intensity days and low intensity days. So day 1, high intensity, day 2, low intensity, day 3, high, low. So you want to alternate there. to not do too much, because if you are, you're at a very increased risk of injury. You have completed another section. Now we move on to section 4 and the central nervous system. Moving on to section 4, nervous system and motor control. In this section, we'll talk about what the nervous system is, how it's related to strength and power training and sport in general, and how we can train it and therefore improve and get better at our sport. In the first chapter of section 4, we're going to look at the nervous system and its components. We differentiate between the central nervous system, which the brain and the spinal cord belong to, and the peripheral nervous system that the nerves are part of. The central nervous system is known as the command center of the body and is responsible for all communication that happens within the body in form of messages and signals. It coordinates pretty much all processes that are happening in the body, like moving, breathing, talking, or seeing. The functions and tasks of the nervous system include the sending out of information from various parts of the body about their current state, like the magnitude of a muscle's contraction. The messages and signals that get sent through our bodies, they regulate the thoughts and feelings, memory and learning, movement and coordination, the senses, and many more. So the nervous system controls pretty much all the processes that are happening in our body. Looking specifically at the central nervous system, it consists of the brain, which is the most important component that controls everything, and is connected to the spinal cord that runs down the spine and is protected by the vertebra. It receives signals that are pretty much like updates from the nerves about how we feel, how we move, or how we think, and is also responsible for sending out the information to the respective body parts over the nerves, over the peripheral nervous system. As mentioned, the peripheral nervous system consists of nerves or neurons that reach down from the spinal cord. There are sensory neurons that inform about the senses, like seeing, hearing, or touching. And there are motor neurons that coordinate the muscles and also help us to move in general or to breathe. All the information from the central nervous system get delivered to the respective body parts within the peripheral nervous system. We differentiate between the somatic nervous system, which is responsible for all voluntary movements, and the autonomic nervous system, which is responsible for all involuntary movements and can be categorized again in the sympathetic and the parasympathetic nervous system, which we will talk about now in the next chapter. It becomes pretty complex and extensive when we go into the details of the sympathetic and the parasympathetic nervous system. We just need to understand the basics. The sympathetic nervous system, or the sympathetic state, kind of means game mode activated. So that's the state where we prepare for all kinds of physical activity, which means our heartbeat increases, our digestion decreases, and the release of hormones like adrenaline, for instance, gets stimulated. All of that is essential for performing our sport and for competing at a high level. So to enter that sympathetic state when exercising is crucial for high performance. The parasympathetic nervous system is the resting state that's being activated. So it enables recovery, regeneration, and adaptation of our muscles. So here our muscles regenerate, we increase our gains and our training capacity, and sleep, for example, is the key factor for recovery and regeneration. And when we sleep, we are in that parasympathetic state. Entering that parasympathetic state is just as important for us because our muscles, they only adapt and they only get bigger in that parasympathetic state. Like our muscles, they don't adapt during the exercise, but during the time between our workouts, after our workout. Therefore, it's critical that we enter that parasympathetic state right after our workout and try to stay in it as long as we can between our workout until the next workout starts. A few ways how we can get into the parasympathetic state easier are meditation or breathing exercises, for example. Then listening to slow and relaxed music can help us get into the state, and to sleep or to take a nap in between can help us as well. How do muscles get activated and recruited? Our muscles don't activate by themselves. They need to be told so by the nervous system. So the nervous system is what allows a specific muscle to get activated. So the central nervous system gives the order to the peripheral nervous system, and neurons, they start to transmit electrical impulses to the muscles. Now, when this impulse arrives at our muscle, it needs to surpass a certain threshold in order to stimulate the muscle cell, which is known as the action potential. If it surpasses that threshold, that's when our muscles get activated and are able to contract. Activating the muscles is not the whole story, though. The muscles also need to be told how hard they need to contract. And that's why we need to be able to recruit motor units. Now, one motor unit comprises a neuron and all the muscle fibers that it innervates. Now, it can comprise 10 muscle fibers or up to thousands of muscle fibers, depending on the size of the muscle. Smaller muscles usually get innervated by smaller motor units as they require finer control, like the fingers, for example, while larger muscles get innervated by larger motor units to generate higher forces, like our glutes, for example. The nervous system recruits as many motor units as necessary for the respective movement. So if we're squatting without weights, it recruits much less motor units than when we're squatting with weights. The skill of activation and recruitment, which is known as motor control, is dependent on the three different factors that are the magnitude of the contraction, the timing and the contraction, and the skill or the technique of the movement. We can optimize those three factors in order to get the best possible outcome, in order to increase our motor control. Heavy lifts, for example, require an increased recruitment of motor units, which we cannot control voluntarily. So when you lift for the first time, you won't be able to recruit as many motor units because your nervous system needs to learn that skill first of recruiting enough motor units. Many early gains in the weight that you can lift, that is to be lifted, are therefore due to neuromuscular adaptations. So increased recruitment, you're getting better at recruiting more motor units to perform the exercise. In this chapter, I would like to give you a quick example of how powerful motor control and neuromuscular adaptations can be, and just how to use it in a workout, how to make use of it. At the end of the last chapter, I mentioned that during the first weeks when starting a new exercise, we are able to get high increases in our motor unit recruitment and therefore a higher capacity of lifting weights. Now, but there is something else that neuromuscular adaptations bring with it. There are studies out there that show that when we are training one limb, we actually also get neuromuscular adaptations on the opposite limb, because we train that neural connection between our brain and one limb, so the other limb also starts adapting. For us, that means that we should be training our weaker limb first, because the other limb, our stronger limb, also will fatigue during the set with the first limb before it even gets trained. Now, the fatigue is only neuromuscular fatigue, but it's still relevant for us. We also should be getting sufficient rest after completing the set of the first limb, so we can still perform the same amount or close to the same amount of reps for the opposite, for the other limb. Another thing that we should keep in mind about that is when we have an injury for, let's say, a broken leg, we can still train our healthy leg and we get some neuromuscular adaptations, some benefits from that training on our broken leg as well. So from now on, when working out, maybe consider to start the set with your weaker leg or your weaker arm, with your weaker limb. Another topic that I wanted to include in this section is proprioception, as it is closely connected to motor control and an extremely important but overlooked factor when we talk about athletic performance. So what does proprioception mean? It basically describes the control of our body in time and space. So it includes balance, but also motor control, so everything from coordination, timing, or skill. It also describes the coordination between the nervous system and the muscle. For example, when a muscle gives feedback to the nervous system about their current position and execution of the movement. Most of the time when we talk about proprioceptive training, it targets the ankle stabilizing muscles, while weightlifting exercises, for example, don't really train those ankle structures, but we rely heavily on them in many sports. Of course, the feet are the only part that are interacting with the ground during jumping, for example. But if the energy is leaking because our ankles and feet muscles aren't properly trained, it doesn't matter how much force, how many forces the muscle of the kinetic chain, so of our glutes, hamstrings, and quads can produce. We're not going to be able to use all of that force for our jump, since our weak ankles won't be able to transfer those high forces. So how can we train proprioception? The most common method for proprioceptive training is instability training, which includes balancing on an unstable surface, for example, a balance board or an air pillow. Now, it could also be balancing on the knee, so kneeling on a stability ball. That would more target the core stabilizers. If you want to do weight training, we can use weights that are filled with water. The body here needs to activate all those little stabilizing muscles that usually don't get trained because the water within the weight is moving and is creating an instability for us. Another option would be balancing on one leg and having an elastic band around the waist, while a training partner is pulling on the elastic band and therefore creating unexpected instabilities. We also could be training with our eyes closed, because if we take a sense away, we have to rely more on other senses and therefore train our internal control of specific structures. So let's say we're running in sports, but we're looking somewhere else, we're looking at a ball, let's say, then we still need to make sure that we're still running without focusing too much on it. Reacting to external influences is about the same concept as having your eyes closed. So we still need to be able to react at any time, even if we're not prepared. For example, if we're balancing on a board or if we're running and catching a ball from a partner, we still need to be able to focus on the one thing that we're doing while being able to catch a ball. There are tons of benefits from proprioceptive training. I can't even name them all, but here are just a few. For example, we get better at coordinating the activation of our muscle groups. So we learn how to co-contract at the right time. And as we've talked about before, the ability to turn co-contraction on and off at specific moments is extremely important if we're explosively jumping but then landing again. With proprioceptive training, we can also increase our maximal force production from the primary muscles, because the stabilizing muscles around the primary muscles contribute mightily to the maximal force output. And by training proprioception, those stabilizing muscles, they learn how to be activated at the right time and how to be activated at all. So with their reinforcements, we have way more maximal strength, maximal force that we can produce. Another benefit is that we increase our reaction time and our quickness. Since training proprioception is basically like training motor control, we're able to translate the signals from the neurons that our central nervous system sends down quicker into actual movement. One of the other biggest things about proprioceptive training is that we can significantly reduce the risk for injury. Now, especially the risk of ankle injuries decreases by a huge margin with proprioceptive training, but also the risk of knee sprains, lower back injuries, and pretty much everything goes down. So next to strength training, proprioceptive training is the most vital method if we want to reduce the risk of injury. So with all that being said, if you haven't implemented or thought about proprioceptive training in your workouts, it's definitely time you give it some consideration, as it's a crucial part and highly beneficial for almost all sports. In this section, we'll talk particularly about strength and are going to divide the term strength into different strength qualities that need to be trained. I'm also going to give you a few examples as how to train the different strength qualities. Let's start off this section by giving an overall definition of what strength exactly is. The official definition of strength says that it's the ability to carry out a load against a resistance. So that means that strength is not just defined by the maximal weight that can be moved, which is obviously an important part of strength, but many people, when they hear about strength, they think about what's the maximal weight someone can lift. But for example, as a high jumper, we need lots of strength in order to take off from the ground, but they might not be able to lift as much as others like bodybuilders or weightlifters. So what I mean to show you with that is that strength has many facets, and that's why we like to distribute strength into different categories. If you remember the force-velocity spectrum, the force-velocity curve that we talked about, we're going to look at that in this section in particular, because there are independent and semi-independent strength qualities that we're going to talk about in a little bit. Other extremely important strength qualities that we're going to talk about in this section are the reactive strength, strength endurance, and the absolute, as well as the relative strength and the difference between the two. Looking at the force-velocity curve here, we have the independent strength qualities. Now, the independent strength qualities include the maximal strength, which is, of course, at the very left side of the graph, where velocity is minimal and the force production is maximal. On the other side, we have the speed, or the maximal velocity, which is where velocity is maximal and force is minimal. The independent strength qualities, they form the foundation for training and all sporting movements, which is why they should be trained first. Which one of the two you should train first depends heavily on the sport that you're doing, whether you need more speed, more maximal velocity, or whether you need more maximal force. The reason why they are called the independent qualities is because they're both trainable by themselves without influencing the other. When we're on the very left side of the spectrum, where we train maximal strength, we're not influencing the speed of the movement in general. And if we're on the very right side of the spectrum, we're training for maximal speed, we're not influencing our maximal strength. Looking further into the force-velocity curve, we have the semi-independent qualities that are trainable by themselves, but they're influencing the other qualities as well. So the improvements that we get in training those semi-independent qualities are also based on the development of the other strength qualities. Now, the semi-independent strength qualities include speed, strength, and strength speed. And we'll get to each strength quality particularly in the next chapters. Strength speed and speed strength are located on the force-velocity spectrum between maximal strength and speed, more towards the center of the curve. When we talk about the most important elements contributing to force production, we refer to all the elements that we already talked about, which is the muscle, which is of course responsible for the active force generation. Then it's the nervous system that's responsible for activation and recruitment of motor units, as well as the coordination of the contraction and the co-contraction, for example. And we have the non-contractile elements, like tendons and ligaments, that are responsible for optimal tension and optimal force transmission without leaking energy. Our overall strength output can massively be changed if we get only one negative influence from one of those three elements, which is why we need to make sure that we train all three of these strength elements. First of all, let's look at maximal strength. Now, the definition of maximal strength is the peak force that the neuromuscular system can produce and can exert over just one single repetition. The maximal strength, therefore, is independent from time, so it doesn't matter how fast you perform the single rep. You can try to lift it slow and try to leave your time with it. It just matters how much force you can generate during the repetition. An athlete's maximal strength is often defined by the 1 rep max, which you might have heard about already. Now, the 1 rep max is the maximal weight that we can lift on a single repetition. So it doesn't matter how much reps we can do. It just matters what's the maximal, the highest amount of weight we can lift on one single repetition. It's also important how we classify maximal strength. There's a difference between maximal isometric strength, maximal concentric strength, and maximal eccentric strength. So how can we train our maximal strength? Well, first of all, we need to find what is our maximal strength, and we can do this by measuring our 1 rep max or by performing the isometric mid-thigh pull test. Studies have showed that there's a correlation between maximal strength measured in the isometric mid-thigh pull test and the jump height, the sprint speed, and the change of direction time. So it's heavily related to performance. We can increase our maximal strength by challenging our current maximal strength. So we're lifting heavy weights, and think of the force velocity curve or the force length curve. We're trying to increase the maximal strength, so we're trying to increase that maximal force output. This can be trained by performing slow and heavy lifts around 85% of your 1 rep max. 85% means if your 1 rep max is 100 kilograms, 85% would be 85 kilograms. So kind of close to your 1 rep max, but not quite there. For slow and heavy lifts, also try to keep the volume low. So let's say 3 to 5 sets of 2 or 3 repetitions only. On the last set, you can even go up to 90% of your 1 rep max. In order to still create sufficient exposure to exercise, usually we go up with sets with time. So when you get more advanced, you can add a set or 2 and even go up to 5 or 6 sets overall. Beware when training maximal strength, because when performing the 1 rep max, there's a high injury risk, which is why we shouldn't just go out there and just test our maximal strength if we have no training experience or if we haven't trained sufficiently in the past weeks. And especially don't do it at all if you don't have a training partner, which you absolutely need for your 1 rep max. The benefits that you get when training maximal strength is an increased maximal force production and therefore also an increase in your muscle mass. You're also going to get increased co-contraction during those slow and heavy exercises and movements, since the agonist, the antagonist, and all the stabilizing muscles, they need to work together in order to produce the maximal force output. Be careful. Too much heavy lifting and too little speed velocity training is going to lead to too much co-contraction and therefore less explosiveness. Maximal strength training is usually very good for our tendons as well, for the stiffness of our tendons. So that means a better force transfer from our muscles to the bones, especially in the beginning when we're just starting with maximal strength training and heavy lifting. The final benefit that I've listed here is that weights can be moved easier. Now, this part is actually really interesting. Let's say hypothetically, your 1 rep max is at 100 kilograms at first. Now you go out to train a lot, do a lot of maximal strength training, and you improve your 1 rep max to 150 kilograms. Now, with that increased maximal strength, if you're lifting 100 kilograms again, you're going to be able to move it easier as before. While at first you had you needed your maximal strength in order to lift 100 kilograms. Now you can move it easier and therefore faster. Therefore, the new force velocity curve with an increased maximal strength would look like the golden graph right here. As you can see with the new graph, when applying the same amount of force, you can now move the same amount of force with a higher velocity. So even though maximal strength and maximal speed are independent qualities, they're still both very important, as maximal strength is kind of the potential for your maximal speed gains. As an example, let's say you're in a small room. Now the room is completely full and you don't have any more space. Now by increasing your maximal force, you're kind of raising the roof of this room. So there's more space in your room, and now there's more space for velocity training and maximal speed training. Then after some time, you fill up the room again, you get some more gains in velocity and speed, and then you can go and raise the roof again by training more maximal strength again and increasing your overall potential. Now let's look at the opposite strength quality, which is speed or maximal velocity. Speed or maximal velocity refers to the contraction velocity of our muscle fibers and defines the maximal possible velocity that we can perform a movement or an exercise at. We are aiming to overcome the highest distance within the shortest time. The distance can be here a change between joint angles. So let's say we're starting from a squat position and we're jumping up. So our joints, they extend from a flexed position. The distance is kind of the change in the flex to the extended joint position. And we're trying to do that as quick as possible, obviously. Of course, our maximal speed is heavily dependent on resisting weights, which can be the body weight during a jump, or it can be a dumbbell during a bicep curl, for example. Now, if it's our body or if it's a dumbbell, in either case, it influences the velocity that the body can be moved at. Regarding the training of speed, we can increase our speed by challenging our current maximal speed and generally by performing fast and explosive movements. Similarly to training for maximal strength, when we're training for maximal speed, we are trying to keep the volume down. Remember, quality over quantity, so we can perform each repetition with maximal speed. When we see a drop-off of 10% of our speed during the reps, that's when we should call it a day, because due to fatigue, we're not actually training for maximal speed anymore. It's better to go up in sets than in reps, but always have a high resting time, like around 1.5 to 3 minutes resting time between those sets. One of the best ways of how we can train our maximal speed is by minimizing the resistance. Now we can do that by using elastic bands that make the body lighter, so it kind of supports our body and therefore kind of reduces the body weight. Now that way we can train for maximal contraction velocity and train our nervous system for the highest maximal possible speed without being too dependent on our body weight. So we're kind of eliminating those high resisting forces from our body weight in order to get our maximal velocity output. The benefits of maximal speed training are an increased neural activation velocity as we train our neural pathways and our peripheral nervous system to activate those muscle fibers faster and therefore can produce forces even quicker. During fast and explosive movements, we're also telling our nervous system to turn off that co-contraction, which is why explosive movements and speed training generally leads more to a decrease in co-contraction, you can say. Lastly, we're training our muscle-tendon interaction and our elasticity, so all the elements that are responsible for storing and releasing elastic energy without leaking. Usually with training, we can increase our maximal strength by a higher percentile than our maximal speed. Let's look at the force velocity curve again when we're training for maximal speed. We have the golden graph here that we saw in the previous chapter when we raised the roof, when we raised our potential. Now with that increased maximal strength, we're using the empty space that we have in our room, if you remember our example, by training our maximal velocity. So you can see the maximal velocity at the end is a little bit higher than before. And at the same time, our force production when lifting lighter weights increases by training maximal velocity. Now, let's look at the semi-independent strength qualities, strength speed, and speed strength. As mentioned before, strength speed and speed strength are semi-independent, so they can be trained individually, but their development is also based on the development of the other strength qualities like maximal strength and speed. Generally, what strength speed means is moving heavy loads fast. So the focus is on strength and speed is kind of the second factor. Speed strength, on the other hand, means moving lighter loads very fast. So the main focus here is speed and strength is the second factor. If we're training for strength speed, we want to lift weight explosively. So we can think of it like kind of a hybrid of strength training with heavy weights and speed training. Now, most exercises for strength speed are quite challenging and therefore shouldn't be done right from the start of a training program, but more at a later point, since our joints, they need to be prepared to handle such high loads. Some exercises for strength speed training would be loaded jumps. So we're jumping with additional weights in our hands and the forces that our knee joint has to absorb during the landing are very high. So we really need to prepare our body for strength speed training. Exercises like loaded jumps or lifting, for example, a barbell in a specific time, they're not just challenging for our body itself, for the structures of our body, but also for our nervous system. Therefore, we can think of strength speed training as an increase in neuromuscular performance. Speed strength training basically includes the starting strength and the explosive strength. Now, starting strength means we want to generate the maximal force right at the beginning of a contraction. And explosive strength is the rate at which an athlete can develop his peak force, so the highest force. One way we can train speed strength is by doing plyometrics, like body weight jumps. If you have a very low body weight, you can carry some light weights and perform jumps with that, as long as the focus is still the speed and not the strength. Here we want to move something as fast as possible, but we don't necessarily want to take away the load factor, like when we're training for speed or maximal velocity. Remember, the speed is the priority, but the strength is also still a factor. Going back to the force velocity curve, it gets pretty obvious why they're called semi-independent strength qualities. So as we can see, by increasing our maximal strength and also by increasing our maximal speed, in both cases, the semi-independent qualities, speed strength and strength speed, also get trained and increase a little bit. In order to optimize our strength speed and our speed strength, they still should be trained individually at some point during the training program, which is why we should still incorporate some fitting exercises into a resistance training program. Now we're getting to the other strength qualities that aren't directly on the first velocity spectrum, but definitely aren't less important. In fact, the reactive strength is arguably the most important strength qualities for many, many sports. The reactive strength is basically the ability to switch from an eccentric to a concentric contraction as quickly as possible in order to optimize the stretch shortening cycle. So reactive strength is limiting the stretch shortening cycle to the shortest possible time. and that is in order to generate high forces in a short time just after a stretch. Here's why the reactive strength is so important. It's kind of the base for most movements in sports. Like during every step while you're sprinting, we're trying to limit the ground contact time and generate the highest force possible for the next step. We're switching from an eccentric to a concentric contraction. Also, when we're jumping, landing, and then jumping right back up again, it's just for most movements in most sports, they just depend on the reactive strength. The way we can track our progress regarding our reactive strength ability is by using this formula, which calculates the RSI, the reactive strength index, which equals the jump height divided by the ground contact time. Reactive strength depends on many factors, so there can be quite some different reasons for why we're not getting the results we want to and why we're having a hard and a difficult time in improving our reactive strength. Just to name a few, it could be due to our ankle strength. Like many people, they work on their reactive strength, but they don't see the improvements they're hoping for, and that's due to a lack of ankle strength. If our ankles are not able to handle the high landing forces after a jump or during a sprint, the ground contact time increases, and therefore we are not as reactive. In relation to that, our body weight also plays a crucial role here, because the more weight, the more ankle strength is needed to carry all that weight. If you're desperate for improvement in reactive strength, if it's just really bad and you can't help it, maybe it's helpful to consider losing body weight by losing fat, or maybe even by stop building the type of muscles that are not necessarily needed for you to improve the reactive strength. Another factor that influences our reactive strength is the neuromuscular response from our nervous system. So that includes our pre-activation before ground contact or the correct coordination of the limbs, for example. During many movements that require reactive strength, what also happens is that there's a resistance from the cross bridges. So the muscle resists deformation. Now, we already talked about this several times, but we are relying on the non-contractile elements like the stretch reflex and the muscle tendon interaction, especially the tendons, to store the energy from the landing and to release it like a spring so we can bounce back up after a jump or during a sprint. As our muscles stay quite stiff during most movements that require reactive strength, we don't sink in too much into a low position, and therefore we rely heavily on all the non-contractile elements. So how can we train reactive strength? Well, of course, it depends on what your limiting factor is. If your limiting factors are your ankles, you could do ankle strengthening exercises like submaximal multilateral hops, just to train all the surrounding ankle structures. Also, calf raises would be beneficial here, or just anything that trains the ankle laterally and the structures all around the ankle. If you need to train the nervous system because you want to improve your neuromuscular response, the limiting factor are usually the ankles. So by using a band to support yourself, as I said, you try to get lighter, we are limiting the ground contact time and taking the limiting factor, which are the ankles, away, and therefore challenge our nervous system and expose it to a demand where it is forced to work even faster. At last, by doing the task we want to improve in itself, we get better at it. So if it's sprinting, go sprint. If it's jumping, go jump. And generally all kinds of plyometrics like multi-directional jumps, hops, or sprints are great exercises that can improve your reactive strength. Now, let's talk about another strength quality that's quite different from the others, which is strength endurance. Strength endurance basically describes the tolerance to fatigue during long duration exercises. It's relevant for almost all sports, like endurance sports, for example, swimming or cycling for a long time, but also for team sports like soccer, tennis, or handball. We always need to maintain at least a submaximal level of force over a certain period of time. Generally, we always need a sufficient amount of aerobic fitness. You can kind of think of strength endurance as the opposite to the independent and the semi-independent qualities, as you're not aiming for maximal strength and maximal velocity. You're trying to keep force and velocity low, but trying to increase the time under tension. You have a longer time period where you produce low forces and low velocities. Endurance training can be performed by performing the sport itself. That is very important because endurance is not always equal. It's not always the same, because many sports, they require different interval-ish endurance qualities, which is pretty unlinear. So you work and then you rest. You work and then you rest. That's how it's the case in most sports. You have a time where you're exploding and then where you're resting. That is why endurance needs to be built specifically for the sport that you're doing. Linear endurance tasks like jogging, swimming, or cycling, all sports where you have a linear speed over a certain period of time, are also very important for building strength endurance as you're developing an aerobic base, an aerobic fitness base, which is also very important for muscle recovery after high intensity exercises. Regarding strength training, if you want to build strength endurance here, make sure that you have a high volume, so a long time under tension, and kind of a low weight, about 30% of your 1 rep max. The last thing that I want to touch on in this chapter is the endurance or the capacity, which is kind of not directly related to strength endurance, but it adds a dimension to the strength qualities. The endurance or the capacity describes the time of recovery after producing force. So if we have a peak from producing maximal strength in an exercise, it describes the time that we need in order to produce maximal strength again. By increasing our endurance or capacity, we are limiting the time in between those two times where we are producing maximal force. An aerobic fitness base and strength endurance build kind of the foundation of our endurance or capacity. So building an aerobic fitness base, building strength endurance, doing linear and unlinear endurance tasks, your own sport, and linear sports, that's going to help you increase your capacity. Let's move on to talk about absolute and relative strength. First of all, absolute and relative strength, they are no real strength qualities themselves. They more serve the purpose of tracking and measuring the current strength capabilities. So they help us define how strong we currently are and how our progress has been. And those tests, they can and they also should be done regularly, as there are many correlations between absolute and relative strength and performance. What is absolute strength? Absolute strength is the maximal force that can be generated, being independent from time and also independent from the body weight. It's pretty similar to the maximal strength, as it tests our ability to produce the highest maximal force that we possibly can. Therefore, with the absolute strength, we don't care about our body weight. We're just trying to get as strong as we possibly can. If it's increasing the cross-sectional area or hypertrophy, if it's gaining more mass, we don't care about that. There are some sports actually where lots of body weight, a higher body weight, is quite beneficial. For example, when we talk about rugby players or linemen in American football. Relative strength, on the other hand, is also independent of time, but it defines the maximal force that can be generated per unit of body weight. There's this formula that helps us to calculate our relative strength, which is relative strength equals the maximal strength divided by the body weight. So we can increase our relative strength either by increasing our maximal strength or by decreasing our body weight, or by doing both, of course. A high relative strength is quite important when aiming for maximal strength with a very low body weight. Examples here would be for boxers or when we're doing gymnastics. When we are looking to optimize our relative strength, the focus for building maximal strength here should be on the neural drive, so increasing our motor unit recruitment and activation rather than building muscle size, rather than building hypertrophy. You can kind of think of it like that. Relative strength defines how heavy the body weight is. So when we get stronger, the body weight seems to be getting lighter. And when the body weight gets lighter, forces can be produced more velocity dominant, as we can move lighter weights faster. Before you go and try to lose body weight now, be careful with that. Many times a loss of body weight also at the same time leads to a loss of muscle mass and therefore a loss of maximal strength. So ultimately you won't improve your relative strength because yes, you're losing body weight, but you're also losing maximal strength. So there's not going to be a change many times. In the final chapter of this section, let's talk about power and where it fits into that force-velocity spectrum. Now, we've already mentioned power quite a few times now, but we haven't in depth talked about it and defined what it actually is. When we look at the physics of power, it's defined by the formula P equals F times V. F stands for the force and V stands for the velocity. What that exactly means is we're trying to apply a strength at a certain speed. Therefore, maximal power would be producing the highest force at the highest possible velocity. When we talk about explosiveness in relation to power, what we mean is we're trying to move higher loads with more speed. When our goal is to produce power, to exert the maximal force in the shortest possible time, that is important for all kinds of tasks like accelerating, jumping, or throwing something. When we categorize power into the force-velocity relationship, we can see that it's located right in the middle of that curve. So it's between strength-speed and speed-strength. Therefore, power includes force as well as velocity. We're trying to aim for maximal possible force with the maximal possible speed that we can get. As a consequence of power in that force-velocity relationship, we get the power-velocity curve, which is represented here. Now, the force-velocity curve shows us that with higher velocities, we can produce less force. Maximal power is reached at about 1/3 of the maximal shortening velocity or the maximal contraction velocity. A real-life example for applying the optimal amount of power would be a cyclist shifting gears. Now, when a cyclist shifts gears, the legs are either moving too fast or they're moving too slow. So they shift a gear in order to optimize their power output and produce maximal power. So cyclists are trying to avoid having maximal velocity when they can still apply some more force, but they're also trying to avoid maximal force when they can apply more velocity. They're trying to produce maximal power, so be right in the middle between force and velocity. Welcome to section 6, the training principles. First of all, let's rewind quickly. So we started this course by talking about the basic structure and the functioning of muscle. We went on how muscles work, on more of a cellular level. Then it got a little bit more practical as we went on to talk about muscle contraction mainly. Next, we got into the nervous system and its role in producing movements. And then last section was about the strength qualities. So we started very theoretical, and with each chapter, except for the nervous system maybe, I tried to make it a little bit more applied and closer to training. In this section, I'm trying to apply the concepts and the strength qualities that we learned in the previous sections. To start it off, I would like to talk about athleticism and give you a way of how I classify it, since all training principles, they rely on the fundamentals of athleticism. We hear the word athleticism all the time, and when we hear it, most people, they just think about jumping and sprinting or being explosive, but it's much broader than that. So one aspect, yes, of course, it's the vertical jump, which relies on different independent and semi-independent strength qualities, as well as developing power, having sufficient mobility to get into the necessary positions, and also the technique. Besides all the strength qualities, the technique is very important for all kinds of exercises, all movements that we do, because in order to get actually good result in your sport, you have to be able to execute the movement properly. So in this case, the technique kind of describes the skill of jumping itself. So motor control and motor learning is very much involved into that. The second component of athleticism is the shiftiness, which includes acceleration, explosiveness, the first step explosiveness, but also, which is kind of overlooked, the ability to decelerate, to rapidly slow down from an explosive sprint and to stop on a dime and to change direction also. While accelerating involves more of a concentric movement, decelerating includes eccentric force absorption and a high amount of stiffness when we're decelerating, and also isometric strength in those low positions and the mobility to even get into those low positions where we have a high shin angle. But being able to stretch into a certain position does not mean that we can safely get into that position in a dynamic movement when we're performing our sport, for example. When we get into a very low position, when we're changing directions, for example, there are much higher forces involved. So we need to train ourselves to get into those low positions in that we can be shifty in. Also here, we need to train the proper technique and the skill to produce maximal force and to avoid injury. Now here, reactive strength also is very important and highly required for that. Another very overlooked aspect of athleticism is motor control. That includes abilities like proprioception, so for example, the hand-eye coordination or the limb control in the air when we're jumping, trying to keep the balance while jumping to make sure we're landing safely. It also includes our body control. So how strong and stable are we during body contact? We need to develop the ability not to get affected by an opponent bumping into you. For all kinds of contact sports, being able to not get bothered by an opponent bumping into you and kind of staying strong, having that body control is a very central part of athleticism as well. Body control also includes the ability to correctly and optimally use our skills at the right time. The last part of motor control includes motor learning, so the ability to learn new skills and perform them at a high level in-game. For strength and power training, it's also important that we know about mobility or flexibility. The question here is, how much mobility is really needed for us? It's quite a complex topic that could be covered in a separate course, and there's a lot of myths to it. but I'll just give you the most important facts that you need to know regarding this topic when it comes to strength and power training. Mobility or flexibility is basically our ability to move freely in high ranges of motion, so reaching high joint angles. The amount of mobility that is needed depends on your sport, and it should be sufficient in order to move safely in required positions that you need to move in while performing your sport. Now, we don't really want more mobility than what's required. Some people believe that when they improve mobility, they can improve their vertical jump or their sprint, but that is not the case. There is no correlation between improved mobility and improved vertical jump or sprint. Of course, if your sprint performance is limited due to mobility, you can't get into the position that the sprint requires, then mobility training might help you. But pushing for more mobility when it's already sufficient for the exercise that you're performing is not going to improve you at the task. Hypomobility is the lack of mobility in a certain joint, so there's a decreased range of motion. In the respective muscle that's hypomobile, you usually feel like a tightness, and therefore you're at a higher risk for strains especially. Hypermobility, on the other side, describes an abnormally great range of motion, and I will tell you why this is probably even worse than hypomobility. When you're hypermobile, you're at a higher risk for ruptures or other more serious injuries, while strains from hypomobility are the more common injury. The overall time that's being missed is higher from the injuries that are caused by hypermobility, as some studies could show. And the severity of the injury is far worse when you're hypermobile. One reason for that is there's less stiffness and less tightness in your muscles and tendons. Therefore, there's going to be more load on the ligaments, which therefore are at a higher risk for injury. Another disadvantage of hypermobility is that the stretch reflex is longer, which means we need to get into deeper positions in order to get the same benefits from the stretch reflex regarding energy storage and energy release. So we can't rely as much as the stretch shortening cycle, as we need more time to pop in and out of low positions. Now, in the case of hypermobility, our tendon is going to be on slack, which decreases our explosiveness because the forces, they get transmitted slower. This is also known as electromechanical delay. So how can we train mobility? The goal here should be to see mobility training as something to increase the athlete's movement options. It's not just how far can we stretch into a position, but also are we able to safely and confidently move in those positions. Our ability to stretch more doesn't mean that we can also withhold these positions under high forces dynamically. Often we have enough mobility to stretch into positions, but we can't access it in a dynamic fashion. So for mobility training, first of all, we want to be able to even be in that position, and then we want to be able to feel and be safe in that position. That is why mobility training is important for hypomobility, of course, but especially also for hypermobility, so we can be safe in those positions where we're hypermobile as well. One way we can increase our mobility is by doing eccentric training, because eccentric training leads to plastic length changes of the sarcomere. Now remember, you only want to do that if it's required for an increased performance for your sport. Another way is to move into a certain position or to fall into a certain position and then catch yourself by isometrically contracting. For example, you're standing, then you're falling, you're dropping into a split squat, and you're contracting isometrically. You can additionally hold some weights in your hand to make that isometric contraction a little bit more challenging. Those kinds of exercises are very important because we're building our isometric strength in those positions where we end up in, where injuries usually occur. Probably the best way that you can train your mobility is by challenging your required positions, by just doing the sport itself. That way, you're training mobility, yes, you're challenging those positions, whatever positions are required for your sport, but you're also combining it with the required strength for your sport and also with all the neuromuscular and motor control factors. Rate of force development is a term that you should know about when you're training. What rate of force development basically means is producing force in a short time. So it describes the velocity at which a force gets produced and transmitted in. Now, just applying high forces doesn't indicate that you have a high rate of force development. It depends on the time in which you produce the high forces. We divide rate of force development into 3 phases, which is the early phase from 0 to 0.15 seconds. Now, this phase is mainly influenced by the nervous system. Then there's a late phase, which is everything from 0.15 seconds, and this one is mainly muscularly influenced. So the first part, when we're trying to rapidly build lots of strength up, is mainly influenced through our neurons. And then after that is when the muscles become active and contribute to the force generation. The phase at where we produce maximal force is from 0.35 to 0.5 seconds. As you can see, the max phase sets in much later than the early and even the late phase. And that is why, if we want to improve our rate of force development, we need to optimize the early phase and the late phase. So shortening the time in which our muscles get innervated and trying to improve that starting strength, that explosive strength. We can't rely on maximal strength when having a high rate of force development because it sets in much later. The components that rate of force development consists of are the starting strength and the explosive strength, the conduction velocity, so the velocity in which the brain activates the muscle fibers, the force transmission velocity, so the velocity in which the muscle transfers the force to the tendon, which is dependent on the muscle slag. That can be improved with isometrics or plyometrics. Another component is proprioception, reflexes, and our general senses, and our co-contraction, because if we co-contract, we activate muscles at least 50 milliseconds before ground contact, which helps us to reach the maximal force faster. Therefore, co-contraction helps us to improve rate of force development, and our maximal strength, which is only going to be a factor later, only during the maximal phase. Before that, all the other components, they define the rate of force development. Of course, a high rate of force development doesn't necessarily mean that we're masters of the skill, for example, of jumping. Like many other qualities play a role when jumping, like our jump technique, for instance. What's the meaning of intent, and what do we mean when we talk about training with intent or training with maximal intent? The concept of intent is kind of a mindset thing that can help us plan our training better and improve the overall quality of our training. It generally refers to executing tasks as efficiently as possible and usually as fast as possible. It's that mindset of trying to be the best, trying to perform the exercise, perform the next rep as efficiently and as fast and explosively as just as good as possible. One way of describing the meaning of intent is having a high neuromuscular output in order to complete a task. Like when you throw a spear, moving the spear really powerful, which is the output, in order to throw it a certain length, which is a task. By having this output and this task, we find ways to organize and find efficient ways. So just by performing an exercise with an actual intent behind it, we already get some neurophysiological benefits. This graphic shows you that our intent influences our skill, which therefore influences the adaptations that we get and the improvements that we get from our training. The intent indicates which adaptations occur in our body from training, how we train, and the results we're getting from our training. For example, if we train for strength speed or if we train for speed strength, it's quite different. So our intent is kind of like the steering wheel of our training. It decides where exactly our workout is going. Our intent could be more behind the speed aspect, or it can be more behind the strength aspect if we look at strength speed and speed strength. That is why the training results that we get, they differ depending on the intent. One question you have to ask yourself before setting an intent for an exercise is the skill needed, or are the muscles for the skill needed? Now, the answer to that question can definitely influence your intent and your overall approach to the exercise. When we talk about maximal intent, we usually refer to the highest intent possible when performing a certain movement. Performing an exercise with maximal intent is going to lead to a high amount of neuromuscular fatigue. It's very challenging to perform an exercise with maximal intent, especially for our brain and for our nervous system. That is why more is not always better. We can't have a high number of reps if we really want to train that maximal intent. Some examples for the adaptations that we get from max intent training, in this case when we're lifting weights, are that we need to generate high forces in a short time in order to move the weight fast. If we are lifting heavy weights with maximal intent, we're training that motor potential and the activation of motor units. So we express maximal force and develop central mechanisms for force production. With light weights, we're more focused on the rate of force development or the timing of the co-contraction and the velocity of the force production. Whenever you're performing an exercise, don't just do the exercise because that's just what you do, but always ask yourself, what's the main focus? What's the main intent, the maximal intent of this exercise? Because if you do that, you're going to get much more out of the exercise and much more adaptations and much quicker. Another important part for training and for training principles is the warm-up. And there's a few things we need to understand about it when it comes to the reason for warm-up and for the contents of what exactly we should do in our warm-up. Often when we think about warming up, we just think about running a few laps, just some cardio training, and that's what many people still do. The main goal here is though not to do cardio training, but to increase the tissue and the body temperature. Now, cardio training can be one thing, but we'll get into it in the next slide why it might not be the best thing to do here. So what we want to do is increase our tissue and our body temperature. That can be done especially well when you're moving in and out of some required body position that you're going to need to perform your sport, that you're going to need in your workout. If you're moving dynamically in and out of these required body positions for your sport, you're going to increase tissue and body temperature, and you're going to warm up the muscle over its whole range of motion, over its whole length. The third main reason why we're warming up before a workout, before exercising, is because we want to activate the sympathetic nervous system. We need to tell our body, now it's time to work, it's time to exercise, it's time to go all out. And then our heartbeat increases, our sympathetic nervous system, the game mode, as I described it earlier, will get activated. So what should we do in our warm-up specifically? What are the contents of the warm-up? We should get our body moving, of course, If you're training for maximal velocity, for example, don't waste your energy doing cardio training right before the workout. So by get the body moving, what I'm talking about more is movements like hops or high knees or jumping jacks. Just something that gets your body temperature going. Another thing that you're probably going to include in your warm-up is like a mobility routine, a stretching routine. Optionally, you can also do this with weights. We don't want to push for more mobility here. Another very good thing you can include in your warm-up are isometric holds. That is very safe. It's not extremely challenging, but it's a great option of activating your muscles. What kind of isometric holds you're doing depends on the workout that's following after the warm-up. So let's say today you're working on your power, so you're doing heavy lifts, you're doing counter movement jumps, maybe you're doing even loaded jumps. Now you're definitely going to need your glutes, so you can do a hip bridge, an isometric hold of a hip bridge in order to activate those glute muscles, and it's going to help you during the workout. Proprioceptive exercises are another great example for something you can include in your warm-up. You could also do proprioceptive training like instability training, training your ankle structures. You can do it at the end of the workout as well, but to start it off, it's also a great option. It's not very tiring, and it takes lots of mental control and lots of focus and concentration. Lastly, the warm-up can be used for isolated exercises. So if you're working on something specific, you have a weakness, like a special muscle that you need to improve on, that you need to train. In your warm-up, you can focus on that one muscle group, that one weakness, whatever it is, and train it isolated. In the best case, there's going to be a smooth transition from the warm-up to the actual workout, so you barely even know when the warm-up is ending and when the main workout is starting. Now that's the best case scenario. The most important thing for the warm-up is that you or the athlete you're training feels comfortable, as it's also there to increase your training motivation and to be hyped for the workout. I wanted to include a quick chapter talking about the concept of specificity. The meaning of specificity is we want to perform exercises that are very specific to the sport. So let's say you're a sprinter and you want to increase your maximal strength. Well, maximal strength and sprinting, it goes together, yes. Increasing our maximal strength can help us raise the roof also for sprinting, but it depends what exercise you're doing in order to increase your maximal strength. Now, let's say you're doing a goblet squat with the maximal weight that you can lift. So a goblet squat, you're going as far down as you can, using the whole range of motion over the whole length of the muscle. Now, when you're sprinting, you're not using the whole range of motion. You're not using the whole length of the muscle. So why would you build maximal strength for your quad muscles in an extended position when you're not even going to need it for sprinting? That's why the concept of specificity is about mimicking the movements or the skills that are required for the sport. The best way of mimicking the sport, of course, is performing the sport itself. But if we want to increase at something in particular, at some specific skill, we should try to design it as close as possible to the sport and perform the skill in a way that it really mimics the movement in the sport itself. Our goal is basically to get specific muscular adaptations for the exact movement that we need for the sport. Now, one example for specific sprint training would be a quarter squat. Now, if we do a quarter squat, so we only go down a little bit, now that's way more specific to sprinting. We don't need to do a goblet squat where we go all the way down. But with a quarter squat, we're just in that range of motion that we need for sprinting. The maximal weight that we can lift in a quarter squat is also much higher than in a goblet squat. Now our muscles are just bending slightly, so we can lift way more weight with a quarter squat than with a goblet squat, and therefore we're training maximal strength much better. We already talked about hypertrophy, and I told you about the disadvantages that come with it. Now, if we're training for hypertrophy, we should aim to get functional hypertrophy. So what is it exactly? Functional hypertrophy is hypertrophy that serves the purpose of the sport. So what we're trying to avoid is to build that artificial hypertrophy, how I'm going to call it, which means doing 4 sets of 10 reps of some exercise. Now, if we're doing that, yes, we're going to get an increase in our muscle size, but is it going to serve our sport? The problem with this artificial hypertrophy is that the muscle quality might not serve your sport as it should be. It's probably going to be mainly slow twitch muscle fibers, and it's going to be trained over the whole range of motion, which you also might not need necessarily. So when you're building hypertrophy, it should be done by specific strength training, going back to the concept of specificity. So stop training with the goal of building hypertrophy. What I mean by that is you don't want to increase the size of your legs if you want to jump higher. Just do the exercises that help you to jump higher, lots of power exercises, speed with maximal intent, doing it as fast as possible, increasing your maximal strength maybe, and the hypertrophy will come automatically. Now, the quality of the muscles depends on the training methods. So for sprinting, going back to that sprinting example, we want to do quarter squats. So hypertrophy should be built from our training. The increase in the muscle size, the hypertrophy that we build, should be a side product from specific strength training, from specificity. Ultimately, the main focus should be we want to get better at a certain movement and not get our legs bigger. Now, if our legs get bigger while doing exercises for that certain movement, that's okay. We should let our body form its shape by itself. Some people naturally get bigger legs when they're doing power exercises, when they want to improve their vertical jump. Other people will have skinnier legs even though they're doing lots of power training, and that's just natural for them. Most bodybuilders, for instance, they can't jump very high. Now, they might have huge quads, but still, they can't jump very high because it's mostly slow twitch muscle fibers. Most high jumpers, on the other hand, have quite skinny legs, or when you look at volleyball or basketball players, the highest jumpers are usually quite skinny. The approach when building functional hypertrophy, as I've said, should be sport-specific exercises that fit the purpose of your sport, whatever you're trying to achieve. Also, very important, quality over quantity. If you want to improve your vertical jump and you're doing as an exercise, for example, explosive squats, so you're lifting as quick as possible, trying to be explosive, it's better to only perform 3 reps or maybe 5 reps maximum, and make sure that all these reps are at 100% speed with the maximal intent. Also, you should be slow and steady. Be patient about the progress. Let your body find the perfect amount of hypertrophy that it needs for your specific sport. Let's get into training our acceleration, or our first step, explosiveness. So what kind of qualities do we need to have, and which options do we have to train it? So the training components that we need in order to improve our acceleration are: we need to have power, we need to develop a high rate of concentric force, our muscles and tendons, they need to interact well together, so our high forces that we produce get also transmitted well from the tendon to the bones and applied into the ground. We need to work on our mobility so we can get into the required positions that we need to accelerate out of. And also, very important, the technique that we have while accelerating. Now, this goes more into the biomechanics, but if our technique is off, if our knee is in a weird position, we might be risking injury here. If we're super explosive though, and we never have any problems with the knee, we shouldn't mess with the technique, because if that's what makes you powerful, just don't take it away. If we don't see any improvements in our acceleration ability, even though we're training a lot, it might be because it's limited because of a poor technique. You could train your explosiveness, your acceleration very specific by doing short sprints. So you're accelerating, stopping again, and then you're just training that start, that accelerating position. So you're being very specific with your training. Doing plyometrics is always a good thing to train your explosiveness in general. Increasing maximal strength can also help with your explosiveness as you're raising the roof. And as I said, power exercises, but it's not just power, also by doing speed strength exercises and maximal velocity, kind of all those strength qualities on the force velocity spectrum, they can help you to improve your explosiveness. Next, let's break down deceleration and change of direction, which is extremely important for many sports, but very overlooked because many people, they don't really train it, but it's an actual quality that is going to make you much better, that's going to elevate you from your competition for many sports. So let's break it down into training components and training methods as we did with acceleration and first step explosiveness. The components that you need to develop if you want to improve your deceleration and your change of direction is your eccentric strength, because you need to be able to slow down high forces. You're going on a full-out sprint and you're trying to stop abruptly. So you need to develop high eccentric strength to slow down your muscles in order to stop and withhold the high forces that are exposed to your knee and to your joints from stopping. You need to develop a high isometric strength as well. Slowing down from explosive movements, it's going to put a lot of forces on your joints, especially on your knee. That is why we have to work on the joint stiffness as well. Another thing that's important, especially for change of direction, is the development of reactive strength. So we're stopping and going into another direction. We need to be reactive to keep that ground contact time as short as possible. Now, with the reactive strength, we have the stretch shortening cycle, of course, that we need to train with that. And lastly, like for acceleration and first step explosiveness, we need to work on our technique, how we decelerate. Again, the biomechanics for our technique also here are very important. If our knee is turned inwards and therefore is more in a valgus position, we are at a very high risk for severe knee injuries like ACL tears, which is why the technique, how we stop ourselves, is also very important. The training options here, of course, we can be very specific, and we should be, by doing decelerations and change of direction. So you can just do some freestyle agility moves. You're just exploding and stopping yourself, changing into a direction. Just be creative here. You just need a little space to do such exercises. Also, performing plyometrics will help you to improve at decelerating and changing directions. A great thing that you can do for developing that eccentric strength is slow and heavy eccentric exercises. So, for example, you're standing on a bench or a box or a chair or whatever, and you're slowly walking down. So your leg muscles are extending. You try to do it very slowly. You can load it up even more, make it heavier by carrying some weights in your hand. Those slow eccentric exercises, as well as isometric exercises, as I've said, are very good for your tendon health. Lastly, next to slow and heavy eccentric exercises, you should also do explosive and light eccentric exercises. For example, you're standing straight and then you're dropping into a split squat position and catching yourself down there. Don't just let your body weight take you down. Try to attack the ground. That way, we're learning how to decelerate our body weight and catch ourselves. You can also load this exercise up by holding weights in your hand, which will make it even more challenging to stop in that decelerating position. I am glad to see that you made it all the way to section 7. Now, we've talked about muscle, we've talked about training, and now in this section, we'll talk about the adaptations that we get from training and from exercising. So we'll talk about how exactly do our muscles adapt after exercise, how can we optimize those training adaptations, and also how can we shorten the time between our workouts, how can we optimize our recovery in order to get the best strength and power gains. In this first chapter of section 7, we will cover just some general principles and terms about adaptation that you need to know. Now, basically, what you should be aware of is that the body is constantly moving energy around. That means after stressing the body, after exercising, we are rebuilding systems that were loaded before. One example here would be our muscles that suffer muscle damage after intense exercises. And in response to that, our body is rebuilding those systems, is rebuilding our muscle. We should never underestimate our body and its ability to optimize adaptations. What I mean by that is our body is trying to be as efficient as possible and try to use less energy for certain tasks. Therefore, the adaptation limit increases in response to exercise. Let's say you're going to run for 10 kilometers. Now, the first time you do it, it's going to be a huge stimulus for your body. You are going to exceed the adaptation limit, so you'll get lots of adaptations. Now, if you get used to running 10 kilometers, if you do it multiple times a week, at some point, your body will find ways to use the energy more efficiently, and it's not going to be able to exceed this adaptation limit anymore. That's why you'll get less adaptations if you constantly only go for a 10-kilometer jog. So when you expose your body to the same stimulus over and over again, your adaptation limit increases and you need more exercise in order to still exceed that adaptation limit, which is why you want to progressively overload. Week 1, you're going to go run for 10 kilometers, week 2, 11, week 3, 12. So you gradually increase the intensity and the volume. A little side note here, that's the reason why cardio training is not the best thing or the single thing you should do if you want to lose fat, because your body will become more efficient and therefore burn less calories. The high metabolic stress that you expose your body to when exercising also leads to a higher metabolic stress response. Now we'll get to stress response in a little bit, but what you need to be aware of here, that by exercising or exposing your body to any kind of stimulus, you're going to put stress on your body somehow, and it's going to respond to that stress in a way. The other basic thing that I want to talk about here is that our body is constantly changing. That change depends on our lifestyle and from the environment that we're in. So this environment is going to define the body adaptations. So it could be the gym, it could be your working place. The stress from whatever you're doing is going to have an effect on the adaptations in your body. If you sit on a chair all day because of your work in a bad position, that's going to have an effect on your body, as well as if you're working out every day. Of course, you're going to adapt according to the stress that you impose your body to. All I want to say with that is be aware that sitting in a chair all day, being in bad positions, whatever you're doing, whatever your lifestyle is, it's going to have an effect on your sport and your goals in general. When we talk about the stress responses from our body after exercising, we differentiate between the general stress response and the specific stress response. The general stress response is basically our body responding to any kind of stress that your body is being imposed to. That could be all kinds of daily movements, things that you do throughout the day, and it's increasing the available energy, just the general energy that you need for any kind of task you do during the day. When you're training for your sport, you should try to activate that specific stress response by performing sport-specific exercises and tasks. Remember that if you put too much stress on your body every single day, your body's not going to be able to regenerate. So those stress responses, they need to be able to regenerate over some time, because otherwise we're going to be overtraining ourselves. The last term that I wanted to mention in this chapter is the load. So there's a difference between external load and internal load. The external load would be the intensity, the intent, so how quick are you doing the movement, how fast, what's your intent, the amount of reps that you're doing. It could be the contraction time, the distance when sprinting or when running, the speed that you're running at, anything like that. The internal load is the response from your body to the external load, you can say. So the internal load includes the heart rate, it includes the stress level or the blood lactate behavior. The external load defines the internal stress or the internal load. That is the message that you should get out of this. Of course, there are other factors that define the internal stress and the internal load, like nutrition or the mental attitude that you have, your mental well-being, and your lifestyle. Those are just a few examples. There are many more factors, but especially the external load from your exercise is going to define your internal load, your internal stress. Next, I want to talk to you about the principle of supercompensation, which is a model that should help you to optimize your training frequency and increase the overall training adaptations that you should get. So that is how this model looks like. The straight green line is the fitness baseline. The green graph is going to be the training progress, your shape, how your shape changes after exercising. So in response to an exercise or to a workout, you are going to fatigue at first. So your overall shape is going to go down. Your energy supply or your muscle glycogen will decrease. After that, you are going to recover from the workout. So that's where the glycogen synthesis happens. And you will return back to the baseline where you started. After that, that's when the supercompensation will set in. Usually that's about 1 to 2 days after the workout. It heavily depends on the intensity of the workout and on your shape overall and on many, many different factors. But usually you say 1 to 2 days after the workout. Now, the supercompensation is kind of the adaptation from your exercise, the positive benefits that you get. So you're going to get a little bit above the baseline, and it's going to last for a few days until it returns back to the baseline where you started. Now, what does this mean for our training? Well, obviously, we should set our next training impulse right during that supercompensation phase. That way, over time, when we progressively overload, we're going to increase our overall shape and our overall adaptations to exercise, therefore increase our overall performance. If you're waiting too long in between your workouts, so you've already returned back to the baseline, you're not going to have a change over time, a change in your shape. You're going to stay at the same level. The negative example here would be if you're already training when you're still fatigued or while you're still recovering. So you're setting the next training impulse too early. Now, when that happens, the arrow that's going up right now, defining your shape progress, will go down and we will be overtraining. So we want to optimize the time between our workouts so we can get this curve to gradually go up to increase our shape with time and avoid overtraining as well as staying at the same level. The key takeaways I want you to get from this is, first of all, the importance of resting. As I've mentioned before, the adaptations, they happen when we rest. They don't happen during the exercise. If you don't give your body enough time to recover, you will be overtraining. On the other hand, if you get too much rest, you won't get any improvements over time. Also, training should be structured and planned well, because otherwise, if you don't have a plan, if you just start doing something, well, we don't really increase that adaptation limit. If we don't have a plan, if we're doing something different all the time without any long-term plan, without any structure, we're not getting anywhere with our training program. You also want to maximize the training efficiency while at the same time minimizing the recovery time. If you're not being consistent with your workout routine, you have 1 week where you train every day and then the next week you're not training at all, well, you're not going to make use of this super compensation model, and ultimately you're not going to increase your shape over time. It's very important that you are consistent and prefer to do at least a little bit regularly than a lot at once and then nothing for a longer time. Another principle that's related to training and training adaptations is the SAID principle. The SAID principle, what it stands for is specific adaptations to imposed demands. That means when you're training consistently, when you're training regularly, and you're making use of that super compensation model that we talked about, the structures of your body, like the muscles, the tendons, the ligaments, the bones, all of those structures, they're gonna adapt to the demand that they were imposed to by thickening and therefore improving their capability of handling even more stress in the future. Besides the adaptation of those body structures, your nervous system is also going to adapt. So you're going to get biomechanical and neurological changes according to the performed exercises. So your brain will learn how to perfectly move those limbs at the right time to improve the technique for the skill, for the movement, and also optimize the muscle fiber activation and recruitment. One example for the SAID principle would be running. So when we're running regularly, the skill of running improves. That means our body becomes more efficient at burning calories, which is due to a survival instinct that sets in. That means less calories will get burned once the body gets increasingly used to that skill. So we adapt to the imposed demand, which in this case is running. If the goal is to lose fat, most people, they just start running and they think by just running they can lose the fat, but that is not necessarily the case. Running and cardio training is one part of losing fat, but you should switch it up because our body needs another stimulus in order to burn calories, since it adapts to the imposed demand. If you're running all the time, well, the first few times you're going to burn lots of calories, but once you get used to it, once you adapt to the imposed demand and your body becomes more efficient, you're not going to burn as many calories anymore. A solution for this, if you still want to lose fat, would be to switch it up. You could do interval running, for example, so that challenges the body and the condition in a different way that the body is not used to yet, and therefore our body is forced to burn more calories. Another option here would be strength training. Generally, what I want to tell you, it's a myth that we have to do cardio in order to lose fat. Basically, what it comes down to, it's about losing more calories than taking in when you want to lose fat, and a new stimulus that our body hasn't been exposed to yet forces the body to spend more energy on performing the task, which ultimately is going to lead to more calories being burnt. Besides running, another example would be to do pull-ups. So in the long term, due to neurological changes in our body adapts to the task and builds biomechanical structures and improves those biomechanical structures that support us in achieving the opposed demand. When we ultimately get better at doing pull-ups, our body gets built for doing pull-ups. Our muscles adapt in a certain way, and also our nervous system, how we activate our muscles to do pull-up perfectly, will adapt. Another thing that I wanted to talk about that can significantly elevate your training adaptations is self-organization and feedback. So what do I mean by that? When we perform an exercise, when we perform a certain task, we should give our brain the feedback about how we performed that certain task. That way, our body is able to self-organize in order to improve at this task and get better at it. As an example here, let's say you're working on your vertical jump. So what you should do is, whenever you're jumping, try to touch something, try to challenge yourself to jump as high as possible, higher than you've ever jumped before. You could, for example, try to dunk the basketball or to jump at the rim, or just look for something in your house or wherever you're training that you can touch. The reason why you should do this is to give your brain feedback about how it feels to jump a certain height. If you're just jumping and not touching anything, just touching the air, then you don't really know how high you jumped. By challenging yourself, by trying to reach something, you're telling your body how high you really jumped. Remember, everything starts with the central nervous system, with the brain. The brain is responsible for the activation and the recruitment of your muscle fibers for the jump. It's responsible for the technique of your jump, the timing of the contraction, the co-contraction. All those things start with the central nervous system and the brain. So giving your brain feedback about a task or an exercise, in this case a jump, is going to help your brain to organize better, because now your brain is like, wow, this jump was really high. How exactly did I do it? How did I jump so high? So you're going to see way much progress and way faster training adaptations that way. From now on, when working out, try to give your body and your brain feedback about the exercise you're doing. If it's jumping, try to touch something. If it's sprinting, ask someone to measure the time. So to see how fast you really sprinted. That way your brain is going to be able to self-organize from the feedback that it receives. This chapter will be about the 3 energy systems of the body when exercising. As we know, when we perform an exercise, our body needs energy. Every process that's happening in our body gets fueled by the molecule ATP, which is the basic energy unit. And ATP provides energy through one of 3 different energy systems. Now, the active energy system depends on the exercise that we're doing, so on the intensity and the duration, for example. Actually, all 3 energy systems are all active at the same time, but the main energy system where our body draws the energy from is different. We can train those energy systems by performing exercises that challenges them. The first of the 3 systems is the phosphagen system. Here our body metabolizes phosphocreatine in order to produce energy. The thing here is that the cell storage for phosphocreatine is pretty limited, which is why we can only draw energy for a short time in the phosphagen system. That means it's only active during short but very high intensity bursts, everything up to 15 seconds. Some examples when the phosphagen system is active are repeated sprints or heavy lifts. The reason why many people, especially athletes, are supplementing with creatine is in order to extend that time of our phosphagen system being active. The body will have additional creatine that it can convert to phosphocreatine and increase the active time for a little bit. Exercises that last a little bit longer, So when the phosphagen system is not active anymore, that's when the glycolytic system becomes active. The glycolytic system utilizes carbs from glucose and stored glycogen for the production of ATP, so for the production of energy. The glycolytic system acts as the primary energy provider from the 15-second mark when the phosphagen system is not active anymore until around 2 minutes, so around the 2-minute mark. Some examples here would be high-intensity interval trainings, 200-meter sprints, all kinds of exercises that are above the 15-second mark but are still kind of short. After surpassing the 2-minute mark, the oxidative system or the aerobic system will take over. The oxidative system utilizes oxygen as well as carbs and also fat for the production of ATP. The thing about the oxidative system is it produces ATP very slowly, but in very high quantities, which is why it's preferred for all kinds of long duration exercises. So if you're doing cardio training, if you're running or cycling or swimming, whatever, any exercise or any task that goes on for a longer period of time, that is when the oxidative system is the primary energy provider. One of the most overlooked factors for muscle recovery and regeneration as well as training adaptations is breathing. Let's start this chapter off with some basics that you should know. First of all, you should be breathing through your nose rather than your mouth. Many studies indicate that breathing through your nose increases your sleep quality and you're going to feel more fresh and more recovered the next day. In order for our nervous system to get into the parasympathetic state where regeneration, recovery, and adaptations happen, we should have a longer exhalation phase than inhalation phase. The inhalation phase is a response to stress, which is why your heartbeat usually increases when inhaling, while the exhalation phase is a response to relaxation, so your heartbeat is usually slower when exhaling. Professional snipers, for example, they are shooting during the exhalation phase between their heartbeats because there's more time between their heartbeat during that exhalation phase. In general, nose breathing is very, very important and it definitely should be trained, especially in your daily life, but also during exercises. You're probably not going to be able to breathe through your nose during high-intensity exercises, but we should really try to do it as much as we can. We have to train our brain for nose breathing, not just our body, so that we do it unconsciously also while sleeping. Dysfunctional breathing is really, really bad, obviously, for us, and some factors that are related to it are, for example, trauma, high stress levels, or asthma. Looking at the biomechanics of our respiratory system, we should make sure that our abs are involved when we breathe and our diaphragm. Utilizing our diaphragm when breathing is very important because it's also responsible for stabilizing our spine. The activity of the diaphragm is visible on the pictures here. When we're inhaling, the diaphragm contracts and is going down. When we're exhaling, the diaphragm relaxes and comes back up. So how can we utilize the diaphragm better when breathing? Well, when we're breathing through your nose, the diaphragm is automatically more involved than when we're breathing through our mouth, which involves the chest more. Breathing through our chest is something that we should avoid because it can lead to lower back pain. The diaphragm is going to be less involved when breathing through our chest, which is why we're lacking that stabilization for our spine. And we're going to have a harder time to get in the parasympathetic state. Basically, how you can feel if you're breathing correctly, if when you lay down on your back, you put one hand on your thorax and one hand on your abdomen, and they both should be lifting equally at the same time when you're inhaling or exhaling. When we're exercising, we should make sure that the inhalation is right before the eccentric phase and the exhalation is during the concentric phase. So when we're doing a push-up and we're inhaling while we're going down, and then when we push up, that's when we exhale. The way you breathe during your training dictates the way you breathe out of your training. Learning to breathe correctly during exercise is extremely important, and we can have lots of incredible benefits from that, which is, for example, we can add additional load if we learn how to breathe correctly. We can also uptake more oxygen from the blood and from other structures. And of course, what I've mentioned now a few times is it helps us to regenerate and to get in the parasympathetic state. Especially when we're training our mobility, we should be breathing parasympathetically. So that's pretty much what yoga is about. There's this quote that says, if you can't breathe through a position, you don't own it. What that basically means is if we cannot be in that parasympathetic state while being in a very mobile position, we don't truly own this position. When parasympathetically breathing, we're allowing our brain to accept new positions that we're unfamiliar with and to be comfortable in those positions, especially when we want to really increase our mobility, get permanent changes there. We can only get that when we do parasympathetic breathing, when we are breathing through a position. Nutrition is a huge topic that could be covered in a whole separate course, which is why I only want to give you some basic principles in this chapter that you need when you're building strength and power. Some of the main principles that you should implement is to make breakfast the biggest meal of the day. By having a big all-around breakfast with lots of protein, you're going to feel less tired during the day. You're going to feel like you have more energy, and it's less likely that you will have cravings for sugar. When you're building muscle to improve your strength and power, also make sure that you satisfy the daily protein needs, which is around twice the amount of gram per kilogram of body weight. If you weigh 80 kilograms, you should eat around 160 grams of protein every day. Now, this protein, you should get it mainly from real food and also from different sources of food. So don't just eat chicken or something. Like, try to keep a balanced diet, try to get your protein from different sources. But I know that you can't get the whole amount just by eating real food. So you can supplement also with some protein powder, with some protein shakes. Another important principle is that you consume more carbs on high intensity days than on low intensity days. You should also always, in general, drink sufficient amounts of water to stay hydrated, and also some additional electrolytes. There's water that contains electrolytes as well. What you want to avoid for a healthy overall diet when building strength and power is pre-prepared food, like fast food, for example. Also things like chips or all kinds of things that are fried. Now, these 5 principles are, in my opinion, the most important when building strength and power, but obviously there's way more that can be considered, way more that make up a healthy overall diet. Many people believe that carbohydrates are bad and they shouldn't eat too many carbohydrates and have like a low carb diet or whatever. But you can kind of compare carbs to the fuel of the body. So if you're not doing any exercise, you don't need it. But if you're training almost every day, or if you're training multiple times a week, especially on the training days, you need lots of carbs in order to perform. You can compare it to a car pretty much. If the car is not being used, doesn't need any fuel. But if you drive the car every day, it obviously needs lots of fuel. Among many others, carbohydrates are also very important for the function of fast-twitch muscle fibers. When you eat carbs, you should prefer complex carbs over simple carbs, as they are more nutritious. Complex carbs would be anything that's made out of whole wheat or whole grain, like whole wheat pasta, brown rice, quinoa, whole grain bread, or sweet potato, and many, many others. Simple carbs would include normal pasta, white bread, or chocolate. The positive aspect about simple carbs is that they provide energy much faster than complex carbs. So if we're doing a workout, for example, right before a workout, when we want to get some extra energy, it would make sense to eat a chocolate bar, for example. Moving on to fats, not all types of fat are bad. In fact, the unsaturated fats, so the healthy fats, are very important for the body, and they include nuts, for example, avocado, olive oil, fish, so the fish oil, all kinds of seeds or olives. The types of fat we want to avoid are chips or anything that's fried pretty much. Before a workout, you should avoid eating fats because they take more time to get digested. So what should you eat before a workout? You should have a meal around 2 hours before, and that meal should include high protein and high carb. If that meal is more than 2 hours before, you will probably be lacking some energy. But if that meal is less than 2 hours before, like only half an hour before, then you won't have digested fully. So that 2 hour mark is about the time when you want to have that pre-workout meal. A study has showed that right before a workout, coffee and grapefruit, especially the combination of the two, can have some performance benefits for you. Grapefruit provides you with vitamins and coffee provides you with caffeine, which is not a healthy thing overall, but it's going to help you get in the sympathetic state, which you need to be in when working out. And it has shown in many studies that you can perform better when you take in caffeine. Now, what you still need to consider here, be careful with drinking too much coffee, because once your body gets used to the caffeine, you're not going to have those benefits anymore. So what I recommend you to do, only drink coffee or only take caffeine a few times a week before your high intensity workouts or before your competitions, only when you really need to have a really high performance today. Otherwise, try to avoid caffeine as much as possible. During your workouts, especially during long workouts, you can have some electrolytes and some simple carbs. So isotonic drinks would be a good thing, or cereal bars. As I said, some carbs that provide you with quick energy. Isotonic drinks or water with electrolytes is better than normal water, because from normal water, you're gonna urinate more often, which leads to the loss of more electrolytes. Right after the workout is when there's the so-called metabolic window, which means that our muscles, they are desperately craving for all kinds of nutrients and are trying to soak up anything they can find, which is why we should take in a high amount of protein as quickly as possible after a workout, but usually you say within 1 hour after. One easy way of doing this is by drinking a protein shake, and here you can and should add some carbs. So what you usually say is 2-to-1, 2 carbs, 1 protein. So let's say you have 20 grams of protein, you want to have 40 grams of carbs. One example, what you could do here is add a banana to your protein shake. You should avoid eating fats right after your workout, and the meal should be around 1 to 2 hours after in the best case. Also make sure you add a high amount of protein and carbs here. Many athletes are using supplements in order to increase their performance or to increase their recovery. While many of those supplements have some side effects or also aren't researched properly, it's kind of risky to be just taking anything that we read about. So this chapter is aiming to give you an overview of some of the safest supplements that you can use without having any bad side effects. Those 4 supplements are very safe, but at the same time, they can be very beneficial for your performance, for your sport, and for your recovery. Number one is the protein powder. Then we have the creatine, we have vitamin D, and fish oil, which contains omega-3 fat acids. Before taking any supplements whatsoever, make sure it's third-party tested. So let's get into the first of the four, which is the protein powder. The protein powder is usually whey protein. There's really no high risk in taking protein powder additionally. You shouldn't rely only on protein powder to achieve your daily protein goals, but it certainly can help you with it. Especially right after exercising, during that metabolic window is when the protein shake, when using protein powder, is very beneficial. As we know, proteins are the number one component that we need in order to build muscle, but it's not just beneficial for muscles, but also for our tendons and our ligaments, for the neurotransmitters and the enzymes in our body, and just overall for our brain. So even if you're not doing high intensity exercises, if you're not an athlete, it can still be beneficial for you to get sufficient protein or by supplementing with protein powder. Creatine is also a very safe and effective supplement that you can use in order to improve your performance. As I've talked about in the chapter with the 3 energy system, creatine can help us enhance that phosphagen system. So during the first 15 seconds of exercise, when we're having a high intensity for a very short time. So creatine can help us drastically improve our performance, especially regarding explosiveness, but also when we talk about endurance training in general. That is why creatine is usually used right before working out. It can also help us speed up the muscle recovery, and there's even studies that show that it can boost our brain function. That's why for creatine, it's the same as for protein powder. Even if we're not high-intensity athletes, if we don't train every day, we can still use creatine and we would have some high benefits from it without having high risks. If we don't get enough exposure to the sun, it makes sense to supplement with vitamin D. Depending on where you live in the world, maybe there's not so much exposure to sun, and that's a good reason for you to take additional vitamin D supplements. But also if you're spending lots of time indoors, if you're working indoor and the sport that you're doing is an indoor sport, in that case it would also make sense to supplement with vitamin D, because also it's very safe and it strengthens the muscle as well as the bones. Many fractures are due to a lack of vitamin D and could be avoided by getting additional exposure to sunlight or supplementing with vitamin D. It also improves the immune system and our overall mood and enhances the heart function. Fish oil includes the omega-3 fat acids and can help us increase our muscle activity and our immune function. It can also improve our heart, brain, and joint health, and generally has an anti-inflammatory effect. That means for overall performance, if our muscles or tendons or whatever is inflamed, we can use fish oil in order to reduce that inflammation. Fish oil supplementation is also very safe and has tons of benefits for overall health, but if you're eating enough fish, it might not be necessary. Generally, try to eat fish as much as you can, multiple times a week, so you can eat fish instead of meat in many situations. In this chapter, I will talk about the most common cause for injury and some ways how we can reduce our overall risk of injury. The main cause for injury is timing. When our timing is off, that is often the case if we haven't done our sport in a long time, if we took some weeks off and then we're getting back to it and just everything feels kind of off. All movements are lacking fluidity, there is no rhythm, our co-contraction is off. So in general, it just feels wrong. That is also the reason why if you took off some time, you should gradually get back to your sport, progressively overload and slowly work yourself back into shape. Training this timing is very difficult to implement though, so if you took some time off, if you're trying to get back into your sport, it's pretty difficult to include the training of timing into your training program because it has to be trained by performing the sport itself. So start training your sport again slowly. Don't go all out on the first day after a longer break. When our timing is off and our fluidity of movement is lacking, our rhythm is lacking, then we're depending too much on the ligaments and the tendons, which therefore are at an increased risk of strains or ruptures. The top 4 factors how we can decrease our overall risk of injury are: number 1, proprioception training. I've talked about proprioception and mentioned all the benefits that it has. At number 2, we have strength training, though I would almost put them both together at number 1 because they're pretty much equally as important. We've also talked about the benefits of strength training, especially regarding the stiffness of your tendons. At number 3, we have nutrition, and at number 4, we have sleep. Knee pain is the most common joint pain that we have in most of the sports. Therefore, I have some options listed here that can help you reduce pain in the knee. First of all, it would make sense for you to strengthen your hips and your feet, so you strengthen your other joints. That way, your hips and your feet are going to be able to generate and absorb forces, which is going to take more load away from your knees. So by simply strengthening your hips and your feet, you can already reduce knee pain. One way of strengthening your feet is by doing barefoot training, because our feet have lots of muscles, and all those muscles, they usually don't get activated too much when we walk in shoes around all day. So by getting out of your shoes, doing proprioception training barefoot, being more barefoot in general during the day is going to help you strengthen your feet muscles and can therefore even help reduce knee pain. Another skill that should be trained is how to correctly fall safely without injuring yourself. Many sports include much body contact, so you're jumping, there's some body contact in the air, you're getting off balanced, and therefore you can't have a safe landing on 2 legs. Therefore, it's better to let yourself fall before trying to absorb all that force by landing on a single leg. By learning how to correctly fall, you're going to help to distribute all the load from the landing on your whole body instead of just relying on your knees to absorb those high forces. When we talk about strength training and weight training exercises, many people move on too quickly to train with weights when they could still be doing body weight exercises that should be mastered first. Of course, in many situations like training for maximal strength or power, we are going to need additional weights in order to get that training stimulus. But many people get into weight training exercises too early, and much of the knee and joint pain comes from that. In fact, many times you could still be doing body weight exercises. Let's say you're doing push-ups. Now, you can always make the push-up more challenging by staying down for 5 seconds and going back up. Now you're doing it for 10 seconds and going back up. So by using the isometric contraction, you can make lots of exercises more challenging while just using your own body weight. The last thing for reducing knee pain or reducing overall pain and injury risk is to work on your mechanics. If it's your sprint mechanics, if it's your jumping mechanics, but especially your landing mechanics. If your knees are turned inwards or outwards, there's a much higher risk for injury, also for severe injuries and for knee pain. One way how you could test if you are overtraining or not could be a jump height test right after your warm-up. Now, if you're deciding to do that, the warm-up should always be the same, because if you warm up differently, then the test result could also be different. If there's a 10% drop-off or more in your jump height from one training to the next, and you can see a trend that with every training your jump height goes continuously down, then that's an indication that you're probably overtraining and that you should have a longer rest or just cut down on the volume. Additionally to that, you can also go for a slow jog, which can help against overtraining. Recovery is key, so we can train more often and therefore build strength and power even quicker. In this chapter, we will cover different recovery methods, and I'll give you my personal top 5 recovery methods. Many of those recovery methods are basically also lifestyle tips, because having a better and healthier overall lifestyle is also going to help your recovery. The first method is active regeneration. What that means is we want to optimize the time between our workouts and not just do nothing between. So yes, we want to rest, but we want to actively rest. So what we can do is do mini workouts multiple times a day, which could be walks or small jogs. Like anything can be just be 10 minutes. Get outside, get moving, get your heart rate up, and get your whole metabolism going. You should also include small mobility or stretching routines over the course of the day. It only needs to be 2 to 5 minutes. Go to a few stretches. Just don't sit in the chair all day. Try to get up as much as possible to get your tendons working again. When you're resting or passively resting, so you're not doing anything right now, your muscles still get supplied with nutrients. Your tendons, though, they won't. So by moving throughout the day, you are gonna supply your tendons with more nutrients. The second method is sleep. Generally, you should get from 6 to 8 hours at least. When you're being very active, you should get 8 to 10 hours of sleep in the best case. Remember that all adaptations, they happen mainly while we're sleeping. So there are many studies that show with increased sleep, we have faster reflexes. We can, for example, increase our sprint speed, and obviously we'll feel less tired over the day. If you're not getting sufficient sleep at night, you could do 15 to 30 minute naps over the course of the day, and that can also help you, especially by getting in the parasympathetic state. To increase your overall sleep quality, make sure that you're not eating, that you're not having a meal right before going to sleep, because your body will put all the energy into the digestion, so you're not going to be able to have real rest while sleeping. A common recovery method that's very popular among athletes are pool workouts. So they have obviously lots of mental benefits. We just love to be in water. We love being in a pool. So that's why it's a great thing to do. From being inside a pool, we also get the micro massage from the water, which can enhance our blood flow. A great benefit about pool workouts are that we can train our structures without overloading our joints. Now, obviously, when we're doing swimming, it's a great way of doing cardio training when we're having knee pain, for example. But also for rehabilitation, the pool can be very beneficial because here we can do very safe plyometrics that are way slower. We're almost like floating in the water. And of course, we have way less load that get on our joints. So it's a great way of getting back into the flow, of getting back into high intensity exercises. In the pool, we can also do great workouts for our ankle mobility. Another very common recovery method is icing the joints after exercising. But this one you have to be a little bit careful with. If the joints need to regenerate quickly for the following competition, so let's say you have another game, another competition on the next day, in that case it makes sense to ice, because you'll take that inflammation away, you'll feel fresh and ready to go much quicker. The effect of icing also depends on the amount, how often you use it. So it's more impactful if you use it less. If you're icing your joints every single day, the effect won't be as impactful anymore. The reason why you have to be careful with icing is because it can hinder the muscle building process. That's why you should only use ice really when you have to regenerate quickly. But otherwise, especially during the off season, if you have sufficient rest between high intensity exercises, high intensity workouts or competitions, then you should avoid using ice and try to recover naturally. As an alternative to icing, you can do a hot-cold therapy that describes the switch between hot and cold. So you can simulate that in the shower. You're showering hot and then you're showering cold, hot and cold again. In my opinion, the most important recovery method is happiness, being happy. Because if you're being happy, you're gonna increase your regeneration, your recovery massively just by itself. It's important to have distractions in your life and other hobbies, other things you like to do besides just the sport itself. So try to live a full life. Don't just listen to others. Don't just listen to what I'm saying, what's good for you, what's not good for you. Sometimes you just need to do whatever you like to do to be happy in general. One thing you can do to make your training and your workouts more enjoyable is just to change the exercises that you're doing based on personal preferences. So there's all kind of coaches or people like me that are going to tell you, you should do this exercise, this is the best for that, blah, blah, blah. Ultimately, when there's two exercises, one might be a little bit better, but the other, you like to do it more, then just choose the one you prefer doing. Prefer the one that fulfills you more, that's more fun for you to do, because then you're also going to perform better. So the top 5 recovery methods. At number 1, we have mental state, and that includes happiness, what I just talked about, but it also includes mentality. How much do you want it? How important is this for you? How much does this sport fulfill you? Because if you love what you're doing, you're going to recover much faster. At number 2, we have sleep, which I also talked about in this chapter. Number 3, nutrition. Number 4, breathing and meditation. We've talked about that already in this section in an earlier chapter. And number 5 is daily activity and mobility. Now that includes active regeneration, but it also includes generally being active. For example, what can help you is to do 10,000 steps every day. If you have the time for it, it's going to help you being a more healthy human overall. And as I've said, being healthy, having a healthy lifestyle is the key for improving recovery. This final bonus section of this online course should help you in creating your own training programs. And I want to give you some basic principles here that you can apply. We will talk about the different training phases over the course of the year and how training changes depending on the phase of the year. I will also give you a framework of how your workout should look like on one particular day and many more other hopefully useful information. In the first chapter of the bonus section, I would like to officially introduce you to the principle of progressive overload, which we have talked about before, but not in depth. What progressive overload basically means is we want to gradually increase the amount of our weekly training days, so the amount of workouts we have within 1 week. When we're just starting after a break, for example, we start by having maybe 2 workouts per week. And then in the second week, we're going to add a workout. We're going to work out 3 times a week. The next week, maybe 4 times. And so we gradually work our way up by gradually increasing the amount of weekly training days. You also want a gradual increase in the exercises per workout, so the training volume. While in the first workout, you start with maybe 6 exercises or 5. The next week, you add 1 more. And with every week or every workout, you slowly increase the training volume. In relation to that, you're also increasing the amount of sets per exercise, the amount of reps per set, and the weight that you lift. Another thing next to this gradual increase is we want to switch up the training in order to expose the body to new stimuli. If we get used to the exercises, even when we increase the load, at some point our body needs a new stimulus. So the goals of this progressive overloading are to avoid the reaching of a plateau. What I mean by that is that we adapt to the stimuli of an exercise and therefore aren't getting many new adaptations anymore. As I've said, we want to switch up our training, keep it different. We need a new stressor because otherwise our body will get used to the exercises that we're doing. We also want to constantly challenge the body so we get steady progress and are consistently improving our training adaptations. By progressively overloading, we're making sure that we always get the maximum of our training. At first, we might not be used to a high volume, but then we increase the plateau, we progressively overload, so we increase the volume with time. That is why, whether we're in shape or whether we're out of shape, we always want to make sure that we're challenging our body. Now, what we want to avoid is overtraining, and you have to be careful with that. Challenging does not mean going way above your limit, because otherwise we're not going to be able to make the most out of our training anymore. We want to limit high levels of soreness. Now, a little bit sore after a workout is totally fine, but we want to avoid being sore for a whole week, because in that case, we're not going to be able to train as much. The same thing applies to fatigue. We can feel tired after a workout, of course, but those high levels of fatigue is what we want to avoid. By avoiding overtraining, soreness, and fatigue, our ultimate goal is, of course, to limit the risk of injury and get used to the progress to our training without getting injured on the way. Progressively overloading is applicable to every kind of training, so it doesn't matter if you're training for maximal strength, if you're training for power, or for endurance. This concept always applies. This next chapter is about the intensity of weekly training days. Here, of course, we want to optimize our improvements and our gains while at the same time avoiding overtraining. And I'll explain to you what you need to be aware of. So what you want to do is you want to alternate between the intensity of the workouts. You're going to have high intensity days, and then you're going to have low intensity training days. Your high intensity days could be about 2 to 3 per week, and the low intensity days 1 to 3, depending on where you are. If you're just starting after a longer break, maybe you're having 2 high intensity and 1 low intensity day. Then the week after, you increase to 2 low intensity days. So you're progressively overloading the amount of high and low intensity training days. The most important factor here is never have 2 high intensity training days in a row, because the goal of this alternation between our intensity is to distribute the load. If we're training with high intensity on the first day, we need the next day to recover. So if we're going high intensity, the next day should be low intensity and then high intensity again. So that is why we have this alternation here. We want to control the amount of load that our joints are being exposed to, especially our knee joint. On the remaining training days per week, which is going to be at least 1 if you're having 3 high and 3 low intensity training days, we want to rest, but as I've mentioned, rest does not mean laying in bed all day. It means actively recovering. So what you could be doing is stretching or some mobility routine. You could go for a massage or for some foam rolling. You can also get out for a walk, but just don't do too much. On those remaining rest or active recovery days, we want to make sure that there are no high forces and no high loads on our joints. What are we doing on high intensity days? On high intensity days is where we're training with a very high impact. That means all kinds of heavy lifts or power exercises are for that day, when we're training anaerobically, so our phosphagen system mainly. We want to use those high intensity days to target the main muscle groups that are required for our particular sport, and also do all kinds of high intensity strength and skill training on that day. Now, when you're doing a team sport like handball, for example, it would make sense to do your skill training where you're playing actually handball and your strength training on the same day. That means your high intensity days preferably should be your team training days. For example, let's say your team trainings are on Mondays, Wednesdays, and Fridays. Then those are the days where you also want to do your high intensity strength and power training as well. If you choose to do the high intensity strength training on Tuesdays, Thursdays, and Saturdays, for example, you're going to have high intensity every single day. And that is why I recommend you to do all kinds of high intensity work on one single day. On our low intensity days, we're training with a low impact. So we could be aiming for mobility, we could be doing some isometric stability training, everything kind of in that aerobic area. On those low intensity days, we want to target secondary muscles that are also very important for certain movements that we need for the sport, but are not like the primary muscles. So this could be the core, or we could target all kinds of weak structures that we have. Let's say your ankles are weak. You need to do some extra training on your ankles. Those low intensity days are perfect to work on all kinds of weaknesses. On those low intensity days, you could be doing low intensity strength and skill training as well, more stationary drills, nothing that is of high intensity, of very high loads. Now, as you might have guessed, those low intensity training days, they should preferably be between the team training days. For example, when your team training is on Mondays, Wednesdays, and Fridays, your low intensity days, they should be on Tuesdays, Thursdays, and Saturdays. What are some important factors when designing individualized training programs for yourself or for your athletes if you're a trainer? The main goal of an individualized training program should be to get better at the sport. Now, this seems pretty obvious, but many people, they're doing all kinds of exercises and they're doing some squats because they want to improve their vertical jump. Just keep in mind that the goal is not to get better at an exercise, but it is to get better at the sport. Exercises, they serve as solutions for problems that we have that can help to build muscle and to achieve our goal. What I mean by that is, don't try to get your squat technique down and try to be the best at doing squats if you're training for vertical jump. Being able to squat more has no correlation with jumping higher whatsoever. That is very important to know. By squatting and increasing the maximal weight that we can lift, we're not automatically increasing our potential for a higher vertical jump. An increased maximal weight lifted during a squat can be due to our squat technique improving and therefore our neuromuscular adaptations getting more used to the squat, recruiting more muscle fibers for the squat, getting better at the technique. But when we're jumping, that's a whole different skill than squatting itself. Basically, what I want to say with that is squatting, yes, can be an exercise to help us solve our problem, which is vertical jump, but training to get better at the squat is not necessarily going to help us to get better at jumping. Usually training programs are based on problems or on weaknesses on which the athlete needs to work on that need to be solved. In order to create individualized training programs, first of all, we need to clarify the individual details about the athlete. That includes the current abilities, the current skills, how good is the athlete exactly. That's why it's very important to track the progress and to keep testing over time, to keep checking for improvements and for the progress that's being made. Another thing is the available time of the athlete. How much time does the athlete have? Maybe on some specific days, you don't have time to work out. So it needs to be clarified. Which days are you going to work out? Which days are the high and which days are the low intensity days? The other thing is the training background or the experience. The content of an individualized training program heavily depend on how the training has been in the past weeks. If the athlete didn't do anything the last 2 weeks, we have to structure the training way differently than if he did some high intensity plyometrics the 2 weeks before. The other aspect here is classifying the qualities of the athlete. That includes all kinds of strength qualities that we talked about in this online course, but it also includes the coordination, for example, the proprioception, everything that might be important or interesting for the athlete's sport. If we're looking for just a single workout, I want to give you a framework that you can use in order to create a workout for one single day. That is the way that any kind of workout could be structured. Again, it's just a framework. It's how I usually do it. But of course, depending on the athlete, depending on the focus on that day, it can differ. So of course, you're starting with the warm-up where you're preparing your tissue and you're getting into that sympathetic state. After that, you're doing some movement preparation, of course, according to the main focus on that day. So let's say you're training your vertical jump. In the movement preparation, you could do some technique work. You're going through the jumping technique. You're not actually jumping. It's kind of low intensity, but you are just preparing yourself and your nervous system for that specific movement that you're going to train. After that, we're moving on to our first emphasis of that day. You should usually have 1 or 2 emphasis. The first emphasis should be your max intent emphasis. So the more complex, the more challenging one. This could be power, so you're doing some power exercises, or it could be maximal strength. In emphasis 2, you're moving on to something less complex, so it could be a drop jump, for instance. So you're training your reactive strength, something that is not as tiring and not as high intensity. Now, this particular framework is designed especially for high intensity training days. Towards the end of the workout, you're doing some specific exercises according to the needs of the athlete. So that could be ankle strengthening exercises, which is really common. Many athletes, many people in general have weak ankles, or it could be working on your hamstrings, anything that the athlete needs to work on, attacking any kind of weakness that you or your client might have. The last part of our workout is the cool down. Here we can do some very low intensity exercises. We could do some barefoot training, get out of our shoes. It can be kind of something fun, kind of refreshing. We could do some pool work or some walking in the sand, for example. During that cool down phase is also where you should do your breathing exercises, your meditation, in order to get back into the parasympathetic state. One great breathing exercise that you can do after every workout is to just lay on your back for 3 minutes, put one hand on your chest and one hand on your core, slowly start inhaling through your nose for 5 to 7 seconds, and then slowly start exhaling from 8 to 11 seconds. You should feel your core and your chest expand equally, so you want to avoid breathing only through your chest or only through your abdomen. Let me introduce you to the periodization model, which is very important to understand when designing individualized training programs. Now, as I've mentioned when I talked about progressively overloading, we are going to switch up the training stimulus after some time. And that is because depending on the time of the year that we're in, our training is going to be different. We're going to need different qualities. We're going to train differently. We're going to have different intensities. So by using the model of periodization, we are organizing the resistance training programs into different cycles. The goal of that is to maximize our performance while at the same time to minimize overtraining. The cyclical periods here are, first of all, a macro cycle, which includes one training year, including the whole season, the whole off season, and everything that you're doing. A mesocycle includes all the cycles within one macro cycle. Now, one macro cycle consists of 4 mesocycles, which are the off-season, the pre-season, the in-season, and the post-season. Within those mesocycles, we have different microcycles where we're focusing even more specific on something. This pyramid right here is showing you the key components of athletic performance. When we are starting with the training program, we usually start with GPP, which stands for the General Physical Preparation. That kind of means we're building our base, we're generally preparing our body for the sport. Here we could be doing lots of isometric exercises and lots of stability exercises and just preparing our nervous system for higher intensities. After that, we're going to be working on the strength. So it could still include isometric exercises, but from isometric, we're moving more towards some eccentric exercises and some concentrics too, but we're basically moving from isometric to eccentric to concentric. After building strength and improving our maximal strength, we're moving more towards power. So we're trying to apply strength at a high speed. And at last, when we get very specific in our training program, when we get very advanced, we're focusing on maximal speed, on maximal velocity. This pyramid is kind of how most resistance training program should be structured, while of course it can always differ depending on the sport and the qualities of the athlete. Generally, we usually start from GPP, move up to strength, to power, and then to speed. The most important aspects or the most important principles that you need to consider in each training phase, wherever you are right now, are the frequency of the training, the order of the exercises, the intensity of the exercises, the volume, and the rest periods. For most sports, one whole year equals one macrocycle. Now let's look at the different training phases, the 4 mesocycles within one macrocycle, within one whole year. The first training phase that we're going to look at, the first mesocycle, is the off-season. Now the main goal in the off-season is to become more injury resistant and in general to optimize our athletic performance. Most of the time, the off-season phase lies between 8 to 12 weeks and consists of 3 microcycles, which include GPP, so General Physical Preparation, strength, and power. Now, during the off-season, we mainly focus on 1 or 2 qualities that we want to develop. We shouldn't use the off-season to say we want to get better at everything, at every aspect of our sport, because depending on your sport, it might be too much. So it's better to focus on 1 or 2 things and really get some visible improvements in those 1 or 2 qualities. During the next off-season, in the next macro cycle, that's when you can focus on something else. In the off-season, of course, you want to train hard to get better at your sport, but you need to be careful. You shouldn't do too much because too intensive programs, they could limit the strength and power gains. Also, if you're doing too much, you might be tired and fatigued once the season starts. That's why, yes, you want to train hard, but you don't want to go all out. Overall, the off-season is there for individualized physical development. The goal during the preseason, so right before the season starts, is to transfer the training and the gains that you get in the weight room to your sport. The preseason phase lasts usually around 4 to 6 weeks, and here you are definitely increasing the intensity. In the preseason phase, you're training more specific to your sport, so more specific tasks and exercises that kind of replicate the sport that you're doing. If you think back to the pyramid about the key components of athletic performance, in the off season, we're more in the GPP, strength and a little bit of power area. Now we're moving more towards power and speed, so more towards the peak of that pyramid. Basically, the main thing that you're doing in the preseason is to apply the trained qualities to the field or to the court or to the track or to wherever your sport is being played at. Now the in-season, during the season, our goal is to maintain the strength qualities as much as we can and even gain a little bit of more strength or gain a little bit of power in some cases. The length of the season is heavily dependent on the sport. Many times it's around 30 weeks or from 25 to 35 weeks in general. The amount of training that you're doing during the season mainly depends on your activity and, for example, the minutes that you're playing in your team. If you barely play at all, then it's going to look different than if you're playing the whole game. It's also dependent on your injury history and how prone you are to injuries, how likely for you is it to get injuries, and of course your age. During the season, you're focusing on sport-specific exercises and familiar exercises. Here, we don't want to expose our body necessarily to lots of new stimuli. We want to stick to what we know and to the exercises that work for us. In addition to that, if fitting for our sport, it could also be great to do some additional strength and power exercises. Again, that is heavily dependent on your activity throughout the season. At last, we have the postseason. Now, the postseason is that training phase right when the season ends and before the off-season starts. The goal of the postseason is detraining, so it's a brief period of detraining, and it is pretty short. It's about 4 to 6 weeks long and usually separated into 2 microcycles. Those 2 microcycles are an active recovery at first, and then the general physical preparation. Now, the first microcycle, our active recovery, should not be much longer than 2 weeks, and we're also not completely resting. We're doing, in the best case, some lighter physical exercises. The whole postseason is generally a great time to expose your body to new stimuli so that we can learn new exercises and improving our motor learning and motor relearning capabilities. In that second microcycle of the postseason, we're basically focusing on GPP. So we're going kind of back to just developing our basic qualities to build that base that we need. While during the season we were very specific, now it's back to overall physical exercises. What's very important during that postseason phase is to develop training routines, to master movement patterns, especially new ones, and to establish generally a higher work capacity again. We can also do some explosive movements. Now, the postseason and off-season is a great time also to work on the amount of fast twitch muscle fibers that you have to move more in that fast twitch area. So the focus shouldn't be on endurance training in that phase. Other than that, the postseason phase should also prepare us physically and mentally for the off-season. A common method that's very popular among many trainers and athletes is contrast training. So what contrast training basically means is that we're doing a superset of a slow and heavy exercise followed by a fast and light exercise that targets the same muscle group. A superset is a set of 2 different exercises. So a normal set would be 10 repetitions of a certain exercise, but now a superset is 10 repetitions of one exercise and then 5 repetitions of another exercise, for instance. By using this method of contrast training, we're basically creating a contrast of the first exercise that we're doing in the superset and the second exercise. So the first slow and heavy exercise would usually be a weightlifting exercise where we're aiming for maximal strength. And then the other exercise, the fast and light exercise, would be more focused on something plyometric, like some kind of jump, something that aims for maximal speed, maximal velocity. An example for one superset could be we're doing 5 reps of a heavy loaded back squat, followed by 8 reps of squat jumps. So both exercises kind of target the same muscle group. The main benefits that we get from this contrast training is that we have an enhanced neuromuscular activation because we have this switch up between learning and applying. So the first exercise, we're learning something, and in the second exercise, we're applying and using that type of neuromuscular activation in order to jump high, for example. There's a study that shows that our jump performance increases if we're doing a strength exercise before that's targeting the same muscle group. By doing contrast training, we're also developing all the different strength qualities from that force velocity spectrum. If you think back to that framework, how you can structure one single workout, if you want to implement some contrast training into your workout, you could kind of combine emphasis 1 and emphasis 2. As always, here it depends what your goal is and if it makes sense. You don't always have to do it, but in some situations you would get probably some good benefits from it.